In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care, and water shortages plague communities, and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
هنا مروا وكانوا قدوة للناس هنا مروا وكانوا قادة أطهار هنا مروا وكانوا قدوة للناس.
Oh man, what a way to start the session. A warm southern welcome to all of our participants as well as educators that are logged on to the session. Sawubona, goeiemorgen, good morning, namaste, assalamu alaikum wa rahmatullahi wa barakatuh. We're very happy to have you on board for the session. This is the final push and final preparation for the grade 12 maths workshop hosted by Awqaf South Africa in association with the Department of Basic Education, the Al Falah College, the thread Awqaf iSkills. Welcome to myself, Hasnain Abdullah, beaming live from the Awqaf SA studios here in Cape Town with Khalid. We'll be taking you through the rest of the program today. We are extremely amped. We've got a team that's on standby in KwaZulu Natal with a cohort of 400 learners. We'll speak to Mr. Singh from the Al Falah College. Please show us some love. Let us know in the comments from which province you are connecting to us from. Let us know from which school you are connecting to us from. These sessions are hosted on Awqaf's YouTube platform. Please subscribe and like. You can refer back to these videos as part of your final examination preparation. Don't worry, class of 2024, we haven't forgotten about you. We're in your corner. We've got your back. Now we're going to be calling on Mr. Dr. Rakesh Singh from the Al Falah College himself and his whole team of educators, and the whole team there with Mr. Cathy as well as his team is looking after the AV technical and logistical requirements for the session. So let's call on Dr. Rakesh Singh.
Thank you, Hasnain. Unlike Cape Town, where you have warm sunshine, welcome to Al Falah College, which is cold, rainy, wet. We hope that those people that are here are going to bear the weather conditions and also concentrate at the same time. I think the good weather will help them concentrate. On behalf of the Board of Governors of Al Falah College, the principal, staff, and our fellow students from Al Falah College, we'd like to welcome all those students that are present here today. We know you come from different schools in the rural areas and you made your way here. The fact that you made your way here, we're going to make sure that our facilitator, Mr. Kota, is going to make your day very productive. And please, learners, make sure that you observe all the ground rules that apply to these conference settings, whereby your phone must be on silent or switched off. We have bathroom facilities on your left-hand side for males and females. Please use them. Our working times for today, the first break is going to be from 10:30 to 11 o'clock. The second break, which is your lunch break, is going to be from 12:30 to 1 o'clock, 1:30, sorry. And fortunately for those people that are on site, we are going to provide a meal for you. So that's taken care of. And the final session will end off at 3 o'clock, whereby we close everything at 3 o'clock and we expect the venue to be cleared by 3 o'clock. And once again, we'd like to also welcome Mr. Kota all the way from Johannesburg. And he's been with us here for our program for the last 7 years. And a program of this nature would not be possible if we don't have the various sponsors. As we said that you're going to get meals today, right? We're going to get Pedro's meals supplied by Pedro's. And for the next few days as well, right, we have people that have sponsored and they will look after the meals only for lunch, that is. Without much further ado, I'm going to ask Mr. Kota to take his seat and continue the program. Thanks again, Hasnain.
Thank you so much, Dr. Rakesh. It's terribly cold in Durban. It's a little bit strange to see the whole team kitted up there at Al Falah. It's very cold in KwaZulu Natal. And yes, it is Heritage Month, where we celebrate our culture, our respective cultures, and so on. But also, here at Awqaf, we would also like to celebrate this culture that has been inculcated and the seed has been planted, a culture of striving for excellence and a culture of learning. So I'm not going to be doing much of the talking. Khalid's going to be taking care of you for today. He's going to be the continuity presenter. Mr. Kota is going to be taking you through Maths Paper 1. Mr. Kota has been with us since inception of this program, and he's going to give you everything that you need in terms of resources to ace that your final maths examination. So just be on standby. The Awqaf SA maths rocket is on the runway. It's fueled up. So let's cue the launch sequence in order to get the sequence, in order to get the session going with Mr. Kota.
Eight, seven, six,
And we have liftoff. Mr. Kota, are you vibing with me today? How are you feeling? Are you energized?
Assalamu alaikum. Good morning. Sawubona, molo, goeiemorgen, namaste, vanakkam, assalamu alaikum to South Africa, Awqaf, and the entire world. All our cohort of learners from all the rural areas and from all the different different parts of KZN. Welcome, welcome, welcome to our final grade 12 maths exam prep for 2024. I hope you guys are as amped and as fired up as we are right here in order to get you your distinction this year. Hassanain, how's things going there in Cape Town? KZN extreme subject requires extreme weather. An extreme subject like mathematics. So yeah, we are here in the cold, weather alerts popping up everywhere, but yeah, fueled up as ever.
What is required, Mr. Kota?
Scientific calculators, writing pads, stationery, and obviously your hydration. We've got, and remember something, this is our program. We're going to do it slightly different from our other years. I'm using a mock paper. I'm using Gauteng's prelim paper as a guide, as a structure. And we're going to be going through the paper today to show you how you can ace your paper. It's all about strategy. It's all about technique. It's all about how to attack that math paper for your final exams. So our first session, inshallah, we should kick off now. And we'll be doing algebra and functions. We'll then go for break. We'll come back, calculus and finance. We then go for lunch. And then we come back and we finish up with probability and number patterns. Game over for day one. So before you know,
round, fight.
here we go. Here we go. I hope Khalid is there. Guys, welcome everybody. All our online cohort of learners, keep the comments coming in. It's you guys who fuel this kind of workshop. So we'd love to see all your comments coming in and see how you are engaging with us. So without any further delay, let's get the show off the road. Khalid, Jazakallah for being there. Hassanain, always a pleasure to have you as my co-pilot, as well as Khalid there from Cape Town. Let's get cracking. Okay, guys. Now, like we always say, when it comes to final exams, when it comes to your final exams, you got to have a strategy. And your strategy is ensuring, number one, and I've picked this up marking matric prelim exams as well. The first thing that you guys are lacking, it's not that you don't know the processes. It's not that you don't understand the systems and the processes. The first thing you need to get right. So if you want to know what do you need to get right, to master mathematics, the first thing you need to do is get your algebra right. Guys, if you don't get your algebra right, you're going to be messed in your paper. And I've seen this time and time again going through the papers. Learners know the systems. You guys know the systems. You know the processes. You get messed up with your algebra along the way. What do we mean in algebra? So what do I want you to fix up? Yes, we're going to go through some questions today. But in terms of your own preparation for your exam, what do you need to fix? You need to fix how to do products. Number two, you need to know how to factorize. Number three, you need to know how to add or subtract, multiply and divide fractions. If you can't do that, you can't do math. And this is the start. This is the seed, grade 12s. If you can't do this, you can't remove brackets, you can't solve for x, you can't do equations, You can't do exponents. You can't do exponential equations. Guys, you are doomed. Honestly, you can't master this. If you haven't mastered this by now, don't even write your final exams. I've seen learners fail. I've seen learners get 22%. I've seen learners, they know their math. You ask them what is derivative, they can give you the answer. You ask them about functions, they can tell you everything about functions. You ask them about finance, you ask them about any section in mathematics, a learner knows. The minute you ask him to start writing it out, he can't do the algebra that's required for that question. And they fail. And many of you are failing because of your algebra. So please, guys, I beg you, our appeal to you, grade 12s, this is a very, very crucial time in the year. You were supposed to have polished this in grade 10. You were supposed to have polished this in grade 11. This is grade 12 now, and it's not too late. You've got those holidays ahead of you. You've got the September break. Spend this time polishing your algebra, because your algebra will be in every single topic in mathematics. So let's get started. One of the opening questions here, guys, remember today we are focusing on paper 1. How's our online cohort of learners doing there? It's everybody all fired up and everybody all ready. Now the first question from this past paper here, they said, now they try and manipulate, they play around with your algebra, but your laws remain. So they tell you, given 2k, watch this, if 2k is equal to x minus 5 into x minus k, the first question they asked you to do, let's all take this one down, find the value of k if x equals 2. And then find the value of x if k equals 2. The first question was 2 marks. The second question was 4 marks. And this is from a prelim paper. This is Gauteng's prelim paper 2024. Take this one down. How are we doing there, guys? All our onliners, are you all in there? Keep our comments coming in there. Khalid, pop up our comments. Let's talk to the learners from across South Africa. Hit us up from where you are tuning in from or logging in from. We've seen Limpopo, KZN, Northwest, all the different provinces. Okay. Question, answer. Shh, girls. Girls. Thank you. Right, here goes. If 2k is equal to x minus 5 into x minus k, find k. If x, read your questions carefully. I know this looks so simple. Many of you have messed it up and stuffed it up in your exams. Find k if x equals 2. So what we're going to do, we're going to circle x. Do this in the exam so you don't mess it up. So the first question you're going to say, you're solving for k. So we got 2k is equal to, instead of x, what must I put, guys? 2. So we got 2 minus 5 into 2 minus k. Again, this is algebra. Remember, we always use BODMAS. Remember, we always use BODMAS. Let's see how's our onliners coming in there. Onliners, hit us up with your comments in the comment section. Khalid, how are we doing there in Cape Town? Morning pumped up and ready to chow math. That's it. And you got it right in the paper. Salman, well done. So let's go. Let's solve. So we got 2k is equal to 2 minus 5 is minus 3. And then we've got 2 minus k. Be careful, guys, when removing your brackets. So 2k is equal to minus 3 times 2, minus 6. Negative times negative is a positive. 3 times k is 3k. Now we got 2k minus 3k is equal to minus 6. Minus k is equal to minus 6. So k will equal to 6. And there we go. That's your first 2 marks. It doesn't matter. It's only 2 marks. try and be as elaborate as possible so you don't make any mistakes. That's the first one. On the left. Let's do the one on the right. Let's do the second one. Find x if k equals 2. Again, substitution. So 2 into 2 is equal to x minus 5 into x minus 2. We are solving for x. In the second one, that's the answer for the first one. This is the answer for the second one. We're now solving for x. So 2 times 2 is 4, is equal to, we FOIL this out. By now you should all know this. X squared minus 5 minus 2 minus 7x plus 10. And now we just solve x squared minus 7x plus 10 minus 4 is equal to 0. Let's factorize that. Equal to 0. X, let's go here. Before we do that, let's simplify at the back. So we've got x squared minus 7x plus 10 minus 4 plus 6 is equal to 0. Let's factorize that. Equal to 0. We're now going to have x. Factors 6 and 1 minus x is equal to 6 or x is equal to 1. You'll substitute each one in there to see which one is applicable and which one is not applicable. Please check your validity. Check which one is valid and which one is invalid. So there we go. That was your first 6 marks in your paper. You could not have failed it, and yet some learners have left this out. I cannot understand for the life of me at the grade 12 level how you can leave questions like this out in your exam. Onliners, how are we doing? How are we doing? Khalid put up the comments there on the side. Let's check the comments. Come there, Siabonga Secondary. We'll get 100% there. Let's get the live comments, the live feeds coming in on the side. Sally Nicole, Boxburg, welcome, guys. Let's go. Right. You've all taken this down. I'm clearing it. I'm throwing you into the deep end. We're picking it up progressively. So let's clear this. We've got this down. You've all taken this one down, guys? We all okay? Let's go up. Right, so I've got it here. Let's go here. The next one. Let's try this one. They tell you the square root of 2 into x plus 10 minus 10 is equal to x minus 12. Let's all try this one together. Remember, this is just a warm-up. We're getting to the heavier ones just now. So, the square root of 2 into x plus 10 minus 10 is equal to x minus 12. Now, guys, if you follow our systems and you do it and you unpack it the way we unpack it here in the workshop, I promise you, you will fly through the exams. Now, something else, grade 12s. Your final exam, 80% of your final exam is your basic stuff. So if you don't know your basics, you're not going to get your distinction in math. So let's go. Let's take this 10 over. So let's go. We go square root. Let's say 2. If you want to, we can say 2x plus 20. 2x plus 20. I just multiplied that out. Is equal to x minus 12 plus 10. So the square root of 2x plus 20 is equal to x. Many of you messed this up in the exam again. Minus 12 plus 10 minus 2. Some of you took over the minus 10 on the other side and you put negative 10 on the other side. How can you do that? That's the biggest mistake you can make. You're throwing away marks for silly errors by taking over a term and not changing its sign. And minus 12 plus 10 is negative 2. Now we can square both sides. Guys, are you all following me? Good. Now let's square both sides. Again, some of you, what you did is you squared each term. You can't square each term. You got to square both sides. The entire side needs to be squared. So this and that will cancel out. What am I left with? 2x plus 20 is equal to, let's remove the brackets here. By now you should know, x squared minus 2 times 2 is minus 4x plus 4. I'm going to move over to the side. I'm moving over to the side, so we're going to have x squared minus 4x plus 4 minus 2x minus 20 is equal to 0. I'm going to put a tick. We all okay there? Grade 12s, we all okay? Lovely. Now continue from here. Continue from here. Onliners, you got it correct. Gabriella says that was easy. Good, Natasha. Guys, hit us up. Talk to us. Reese, let's go. So we got x squared minus 4 minus 2 minus 6x. 4 minus 20 minus 14. Yes or no? No. Minus 16. You see? 4 minus 20 minus 16 is equal to 0. Let's factorize that equal to 0, guys. X. Factors of 16 to give you a 6. 8 and 2. Very good. Negative, positive. X minus 8 equals to 0. X is equal to 8 or x is equal to minus 2. Check your validity. Check which one is valid and which one. Check validity. Whichever one is valid. Sometimes both are valid. Sometimes only one is valid, one is invalid. Your left-hand side must equal to your right-hand side. Are we all okay with that, guys? Good. Now the next one, the inequality. Now we're coming to inequalities, guys. Now remember this here, 24 marks of your paper is your algebra. You want to make sure you get full marks. We had learners who only scored 12 out of 24, 8 out of 24. Why? This work has been shown to you from grade 10. At grade 10, at grade 12 level, we cannot be teaching you this from scratch again. So let's clear this. Let's go into the inequality. So you've all taken this one down. I'm sure everybody has got it right. Very good. Let's go. Okay. Now they gave you this one, and the next one, we did it in our workshops before. So if you've logged on to the Awqaf workshops on YouTube before, if you've watched all our previous workshops, almost in every workshop I do this example, and here it came out in the prelim paper. Less than 0. Solve for x. Come grade 12s. At this point in time, watch here. 3 to the power x is an exponential graph. This exponential graph, a 3 to the power x graph, is there, greater than 0. So can it ever be less than 0? Can this graph ever be negative here, less than 0? No. So therefore not applicable, not valid. That's not valid. Your answer is x minus 5 less than 0, x less than 5. This one on the left, this solution, not valid. Because 3 to the power x can never be less than 0. Please, this is an easy problem. There's only one solution here. X minus 5 less than 0, and you solve for x. X less than 5. Yes or no? So even, guys, don't get confused in the exam. I'm going to clear this. I want to show you something. What if the question looked like this? So whether the question looked like that or whether the question looked like this, a half to the power x into x minus 3 less than 0. It's the same thing. Can a half to the power x ever be less than 0? Now, although this is a negative exponential, although that's a negative exponential, it will go like that. Can it ever be less than 0 here, below your x-axis? No, so not valid. X minus 3 less than 0, x less than 3. That's your final answer. This one is not valid. Are we all okay, grade 12s? Excellent. Let's see, how's our onliners doing there? Onliners, how are we doing there? Easy peasy. Right, lovely. Now, I want to show you something else. Right, watch this one. I'm clearing the whiteboard here. I just want to show you something else here. In inequalities, this is the new style of them asking. Remember, every year, the department comes up with new styles of questions. Yes, a lot is the same as previous years. So working through past papers is absolutely important. But the new style of questions. Now watch this, guys. If they tell you 4 minus x into, let's say, 2x plus 3 less than 0. Okay, now what are your two critical values here? Now watch here, guys. This is the way we do that. Be careful with this, where they have a negative x in the bracket. So be careful. So what are our two critical values? What are our CVs here, guys? 4 minus x equal to 0, minus x equal to minus 4, x is equal to 4. Yes or no? And then you're going to have 2x plus 3 equals to 0, 2x equals to negative 3, divide by 2, x is equal to minus 3 over 2. Yes or no? Now, because it's minus x here, and minus x times 2x will give me minus 2x squared. This is a negative parabola. Are you following? Are you listening to me? So now take the 4 and put it there. Take the minus 3 over 2 and put it there. And now less than 0. Where is this graph below? Less than 0 means below your x-axis. So where is this graph below? It's below there and it's below there. Are you guys following? So here's your two answers. X greater than 4, all your x values to the right of 4, or all the values to the left, x less than minus 3 over 2. There's your final answer for this question. It's a negative parabola because you got minus x in the brackets. And this one has been recurring in all the papers. So I got a good feeling in your final exams, you're going to get one like this with a minus x in the brackets. We're going to do one more inequality, and then we're going to go into the simultaneous that they gave. Slightly different. Gauteng always asks slightly different simultaneous equations, but they're not difficult at all. Guys, remember, after this weekend, you should be fully prepared for final exams. As well as, and if you still feel like you need more, go to the Awqaf on YouTube, Awqaf SA, the handle, and go through all our previous workshops as well. A lot of practice, lots of questions there for you to get used to it and for you to master. Onliners, how are we doing there, guys? How are we doing? Everybody all okay? Let's try the next one. The next inequality. Right, so you want another? So these were, so you want to hit you up with a more difficult example. All right, let's try this one. In inequalities. Let's see if you guys can try this one out. Okay. What if I told you 2 over x minus 1 less than or equal to 8? Question, solve for x. After this one, I'm just going to show you. Maybe they may ask you, maybe they might not ask. I know they ask you only quadratic, but I want to show you a cubic inequality after this with 3x values. So come onliners, try this one out. 2 over x minus 1 less than or equal to 8. That's a 2. I'm still getting used to our new online whiteboard. Quite different to the Google Jamboard that we used to using over the past 10 years. Come onliners, let's get this one right. This question is worth 6 marks. This question is worth 6 marks. Wonder Mash, isn't it supposed to be in between the numbers? No, because it's a negative exponential. In a negative exponential, between the two numbers means above. It's greater than or equal to. You wanted less than. I hope that answers your question. That was the catch in the problem. Now, I hope many of you in this question here, please do not tell me you made this 8 over 1 and cross multiplied. Did you do that? Who says yes? Wrong. You will get 0. You will get 0 if you did that. In an inequality, you never get rid of the denominator. In an inequality, take this down. In an inequality, you never get rid of denominator. So what do? We take this on the other side. So it's 2 over x minus 1 minus 8 over 1 less than or equal to 0. Your right-hand side must always be 0. If you listen, you will get it right. Although we've corrected you guys so many times on this kind of a problem in almost every workshop, yet when it comes to exams and we're marking, learners who have been part of the workshop still go and get rid of the denominator. How can you do that? Are you asking to fail? Are you begging the government, please fail me? Right. So now what we do the LCD. Is x minus 1. So x minus 1 into x minus 1 once. 1 times 2 is 2. Minus 1 into x minus 1, x minus 1 times 8 is 8 into x minus 1. Your LCD, lowest common denominator. No rocket science here. Let's remove the brackets. 2 minus 8x plus 8 over x minus 1 less than or equal to 0. I just removed the brackets. Now let's continue here. Minus 8x, there we go. 2 plus 8 is how much? 10 over x minus 1 less than or equal to 0. I'm going to put a tick there. You all understood that. I just simplified it. Yes or no? Right. Pay attention. Now take out the negative. You can take out the highest common factor. I'm taking out negative 2. I'm left with 4x minus 5 over x minus 1 less than or equal to 0. Now we divide by negative 2. So we divide by -2. So I'm left with 4x minus 5 over x minus 1 greater than or equal to. Why greater than or equal to? Because we're dividing by a negative. The inequality changes over. 0 divided by -2 is still 0. Yes or no? Right. Now, what are our two critical values? What are our two critical values? So we got 4x minus 5 equals to 0. 4x will equal to 5. X will equal to 5 over 4. Or x will equal to 1. Yes or no? But it's an inequality. These are just our critical values, CVs. Now remember, what do we need to do now, guys? It's a positive, so you can put it as a positive parabola if you want to. Why? Because we got two CVs. That's 1 1/4 and 1. So put the lower number here and put the higher number there. Right. Greater than or equal to 0 is above my x-axis. So we put or. To the right, x greater than or equal to 5 over 4. Or to the left, x less than or equal to 1. But be careful, that's not our final answer. Can x equal to 1, guys? Can x equal to 1? 1 minus 1 is how much? Can I have 0 in the denominator of a fraction? No, so we take away the 1 equal to sign. So x can't equal to 1. So you just put less than. And here's your two solutions, guys. There's your two answers. Please make sure you get this right. Learn this for your exam, just as a preparation. Onliners, did you guys get this one right? How many of you got this one right online? How many hours do you need to study to get 90%? You need to master everything in our workshop, obviously, and probably work through about 5 or 6 past papers, maybe 10 past papers, and master them, memorize them. Okay, there we go. Right, now let's give you the simultaneous equation that they asked you. Let's give you the simultaneous equation that they asked you in your exam. You guys all took this one down. Please learn the art of unpacking this one. Don't mess it up in your exam. Right, for those of you who have taken this one down, you can start with the next one. The square root of 3 to the power x multiplied by 9 to the power x is equal to 27. And then x plus 4y squared is equal to 6. For 6 marks, solve for x and y. Solve simultaneously. Then I'm going to show you something what to do with logs when you see a log in the next question. Now guys, I can't believe how many of you have stuffed this up royally in your prelim exam. This was marks for jam. It was marks for free. Guys, this is such a crucial point in the year. That if you can master this as we're doing it today, you'll be fully prepared for the exams, and we're hoping to get distinction after distinction after distinction in our final exam. Say amen. Now, I want you guys to recognize something before you do anything. Watch here. The minute you see a 3, a 9, and a 27, you know you got to convert it to base 3, yes or no? So all we're going to do now, this is equation number 1, this is equation number 2. Let's get rid of the third sign. So this is 3 to the power, inside power divided by outside root. So it's x over 2, or half x. times the number 9 is 3 squared to the power x is equal to the number 27 is 3 cubed. So that, if you would have got a heart attack if you had to be marking some of the scripts that I've been marking and you see the, oh my word. Oh my word. To see what a grade 12 learner wrote. Some grade 12 learners, it was actually scary. They came up with their own mathematics. You think they're Einstein. Times 3 to the power 2x is equal to 3 to the power 3. Be careful, you're multiplying and bases are the same. We add the powers. So it's 3 to the power a half x or x over 2 plus 2x is equal to 3 to the power 3. Now the 3 and the 3 cancels out. Now you are left with, okay, on this side here, okay, let's just put it here. I'm going to move up from here to here. You're now going to get a half x plus 2x is equal to 3. We got rid of our bases. Our two bases were the same. Right, now you can multiply. If you want to, you can multiply everything by 2. So let's multiply everything by 2. So that would be x plus 2 times 2 is 4x is equal to 3 times 2 is 6. X plus 4x is 5x is equal to 6. So x is equal to 6 over 5. Yes or no? Right. X is equal to 6 over 5. We can take this and put it back into here. We can take this from this equation and put it into there for every x. So you can circle it. So let's do it together. 6 over 5 plus 4y squared is equal to 6. Let's multiply. If you want to, we can multiply everything by 5. So that means we're now going to get 6 plus 4 times 5 is 20y squared is equal to 6 times 5 is 30. I'm going to move up here to the side. I'm moving up here to the side. So I got 20y squared is equal to 30 minus 6 is how much? 24. Let's divide by 4. Let's divide by 4. In fact, what you could do, you could say y squared is equal to 24 over 20. Y squared is equal to 24 over 20. And now we can just go to our calculator and solve for y. So the square root of 24 over 20, the square root of 24 over 20, and you get 1 comma, if they say correct to 2 decimal places, you can have y is equal to 1 comma 1 or y is equal to, no, that's it, 1 comma 1. But you must get 2 solutions here. Minus 1 comma, it's going to be the difference of 2 squares. So it will be plus 1 comma 1 or minus 1 comma 1. Right? Y squared is equal to plus or minus the square root of that. So it's plus or minus 1 comma 1. And there we go. There's your answer for it. There is your answer for it. Now I'm going to show you what to do with logs. And then I'm going to give you a higher order question with regard to logs. Onliners, did you all get this one right? Did you get it? You might have tried a different way. You might have tried, but you had to have gotten rid. Where is the? Oh, it was 9 to the power y. Sorry. Oh, okay. No, it's fine. Okay. The actual question had a y here. It's fine. Don't stress. Don't stress. We do it exactly the same. So even if the first one, sorry about that. So even if the question was the square root of 3 to the power x times 9 to the power y. Sorry, I didn't see that. But it's fine. Even if they had, guys, we do it exactly the same way. Even if you had the square root of 3 to the power x times 9 to the power y was equal to 27. You do it the same way. 3 to the power x over 2 times, this would be 3 to the 3 squared, so it's 3 to the power 2y is equal to 3 to the power 3. 3 to the power x over 2 plus 2y is equal to 3 to the power 3. 3 and 3 will cancel. X over 2 plus 2y is equal to 3. Multiply everything by 2. X plus 4y is equal to 6. You could have done it like this. And then, so we can say x is equal to 6 minus 4y. And then the other equation was x plus 4y squared was equal to 6. So x is equal to 6 minus 4y squared. So if x is equal to this, and x is also equal to that, I can now say 6 minus 4y is equal to 6 minus 4y squared. Yes or no? If x is equal to that, and x is also equal to this, I can make these two equal, and now I can solve for y. So I can bring that on the other side. I'll have 4y squared minus 4y plus 6 minus 6 will give me 0 is equal to 0. I can take out 4y as my highest common factor into y minus 1 equal to 0. Guys, are you following me? Are you following me? This is if I change that to a y. So now you're going to have 4y equals to 0. So y will equal to 0 or y will equal to 1. And now you can put that into any equation. X is equal to 6 minus 4 into 0. Or x is equal to 6 minus 4 into 1, and you'll get your 2x solutions. Yes or no? Well done, well done. Thank you for that. Thank you for that. I didn't see that. Okay, now that question that came out. Okay, let me first show you what to do with a log. Let me first show you what to do with a log. Right, so I think we all got this. South Africa, we all okay. I think we all on a good trajectory. We know exactly where we're going with these simultaneous equations. Right, let's have a look at this one here. Watch this one, guys. So if they told you, let's say log log x to base 2 is equal to 4. Now, guys, I know I'm not supposed to be showing you at this stage in grade 12. I seen learners write this as log 2x. Can this and that be the same? No ways. This is log x to base 2. Remember, it's in the same line. It's log of a number to a smaller base. Now, it's very important that you people write the format correctly so you know what to write in your exams. Now, this is what we call standard form. What do we call it? Right. How do we solve for x? How do we solve? How do we get rid of the log? You must have it in the standard form. Then we use what I call the smiley face method, or the winky eye. You start from the base. There's your smiley face is equal to that. So you start here at the base. This is called the base. That is called the base. The base to that power is equal to that will always be your answer. So we start 2. There's it. We start at the base. To the power 4 is equal to, now we move that way, is equal to x. So x is equal to 16. Are you guys with me? So even if it looked like this, even if I told you log 8 to base x is equal to 3, doesn't make a difference as long as it's in this form. Log of a number to a base. This is standard form. We start from the base. There we go. X to the power 3 is equal to, we move that way, is equal to 8. So x is equal to the cube root of 8. X is equal to 2. Yes or no? Right? make a note of this. This is how you remove a log. This is how you remove a log. Now I'm going to take a question from a past paper. Right. Let's see what it looks like here. Given that 4 to the power m, now they're going to ask you about your log laws to see whether you can introduce a log and you can solve a log equation. Onliners, how are we doing? We all understanding this? Are we all good? Thumbs up. We wrapping up. Got it right in the paper. Well done, Salman. Well done, well done, well done, guys. Remember, what's more important or as equally important as what we calculate is what we discuss. Remember, the discussion is very important for you people to understand what to do. So I'm answering this as if we are writing this in our final exam together. So let's see if you guys can do this. They say, given that 4 to the power m, take this one down, 4 to the power m is equal to p into 2 to the power 2m minus 1 plus p. That's what you are given. Show that m is equal to, they want you to make m the subject of the formula. So the minute they ask you for m, you already know m is in the power. So either we're going to use exponential equations, but in 99% of the cases, what are we going to be using? Logs. So m is equal to a half log 2 into 2p over 2 minus p. That's what you got to show. If this is given to you, that's what you need to show. That means we need to start here. We need to make m the subject of the formula. Do you guys want to give it a go on your own? You want to try it? Come on. No. Now guys, if we got an m on the left hand side and an m on the right hand side, we want to get them on the same side. What do we want to do? We want to get them on the same side. Come onliners, let's see you guys crack this one. This one came out of another province's prelim paper. This came out of another province's prelim paper. Gabriela getting it right. Anele, yes. Judith, yes. Well done, South Africa. Well done, learners. Right, let's play around with this. Let's have some fun. Okay. So I don't have a memo. What we're going to do, let's see if we can get this on the same side. So 4 and I get 2 to the 2m. So watch what I'm going to do with the 4. The 4, I'm going to make it 2 squared to the m, which is 2 to the 2m, minus p into 2 to the 2m, right, times 2 to the minus 1 is equal to p. Right, I took this on the other side. Be careful, guys, what I did. I took this entire term onto the other side. That's why I made it minus. Are you guys following? Right. Now algebra. So we're going to have 2 to the 2m minus p into 2 to the 2m times 2 to the minus 1 is a half. Yes or no? 1 over 2 is equal to p. Yes or no? Right. So watch what I'm doing. I'm just structuring it so it makes sense to me while I'm working it out. 2 to the 2m. Now remember, that's over 1, that's over 1. minus, I'm going to take out this 2 to the 2m here. And then I'm left with p times 1 is p over 1 times 2 is 2. So that means I'm left with p over 2 is equal to p. So I'm going to put a tick there, I'm going to put a tick there, I'm going to put a tick there. You all understood that? Yes or no? No? Who says no? Right. Okay, so let's go back here. Let's go back to the second tick. Do you understand what we did in the second tick when I took this entire term on the other side? Right. 2 to the minus 1 is a half, so you understood that step. Right. Now I just brought this to the front. P times 1 is P, 1 times 2 is 2. Now do you understand it? Still the same. P times 1 is P, 1 times 2 is 2. Yes. Good. Right. Pay attention now. Right. We've got two terms. I got a term there and I got a term here. What's common in the two terms? 2 to the 2m. So 2 to the 2m, and what am I left with? 1 minus p over 2 is equal to p. Yes or no? Right. Now, in my brackets, I can find the LCD, the lowest common denominator. So 2 to the 2m, that's 1 over 1. My common denominator here, that's equal to p, is 2. 1 into 2, 2 times 1 is 2, minus 2 into 2 once, 1 times p is p. Right. Now I want 2 to the 2m alone on this side. I want 2 to the 2m because I only want m. So I'm going to multiply this side by 2 over 2 minus p. Right? You multiply it by its reciprocal, by its opposite. What I do on the left, I need to do on the... I'm putting a tick there. You all understood what I did there? Good. The 2 and the 2 will cancel. The 2 minus p, the 2 minus p. So what am I left with? 2 to the 2m is equal to, that's over 1, 2 times p, there we go, is 2p, over 1 times 2 minus p is what? 2 minus p. Obviously, I'm not yet done, but we know we're getting there. We're not yet done, but we know we're getting to our final answer. Yes or no? Can you guys feel the heat? It's getting hot. Onliners, are you coming right? Are you winning? Right, let's go. Right. We're not yet done. We're not yet done. So now we got 2 to the power 2m is equal to 2p over 2 minus p. I want to make m the subject of the formula. So what do I need to do, guys? Don't you attach a log and you attach a log? Yes or no? So now we got log 2 to the power 2m is what? If I attach a log to the left, I got to attach a log to the right. So it's 2p over 2 minus p. Yes or no? Right. Now what happens after you attach a log? The power becomes the base. It drops. So we say 2m log 2 is equal to log 2p over 2 minus p. Right. Now watch here. Now watch here. This is a very important step. Now we divide by log 2, we divide by log 2. Now I just want to see something. How did they want us to give us the... Oh yes, correct. No problem. I'm moving over from here to here, guys. So now 2m is equal to log 2p over 2 minus p divided by what, guys? Log 2. Now it's to the same base, so therefore 2m is equal to, if it's to the same base, then you keep the log, and now you've got that denominator becomes your base. That denominator, log, so now you're going to be left with log 2p over 2 minus p to base 2. Whoops, what happened there? What happened there? Choose my preferred region. What's going on here? What? Must I just click here? No? Whoa. Okay, something happened here. Oh. Something happened here. There we go. Thank you so much. That's why we need back-end support. Right, here goes. Right. Now we want m. We don't want 2m. So we divide by 2. Here's your final answer. Therefore, m is equal to, we divide by 2, a half log 2p over 2 minus p. And there we go, guys. That's your final answer. That's your final answer. I know it looks like a mouthful, but it's actually really easy. I promise you this is not difficult at all. This is not difficult at all. I'm just trying to think. Okay, take this one down. Take this one down. Take this one down. This is not a difficult question at all, I promise you. This is not a difficult question. How's our time? How's our time? How are we looking for time, guys? 10:15. We got 15 minutes before we break. Onliners, are we winning? Are you guys coming right there? Easy, easy. Lovely. Lovely. You see, guys, what's important is to remember this law. I just want to see something here. Right, you've taken this one down. Who's still writing? One person, right. Take this one down. I want to show you guys something. Those of you who have taken it down, you can just focus on the left-hand side of the board here. Remember, guys, remember, if you have something like this, so let's say I told you a to the power 2x is equal to b. Pay attention to this. If I asked you to solve for x, now imagine they gave you something like this and they told you solve for x. Now what you can do, because you're looking for x, we're doing the same thing. I'm just reiterating the concept for you so that you understand what we're doing. Right, watch here. We attach a log, So log A to the power 2x is equal to log B. Yes or no? Now, pay attention. Now that comes to the front. So 2x log A is equal to log B. Do you agree with that? Now we want x. Remember the question says solve for? So now 2x is equal to log B over log A. So 2x is equal to, the minute it's like this to the same base, we say log, the A becomes the base A, the denominator becomes the base B. I'm just teaching you that concept so you understand. Now, you can say times a half or divided by 2. So x is equal to a half log AB. There's your answer. So learn this one also. If they had to ask you to solve for x in terms of A and B. Right. Guys, time-wise, how are we looking on time? 10:19, we got 10 minutes left. We've got 10 minutes before break. Right. I want to start with functions. We're going to continue. I'll stop in 10 minutes time. And then when we come back from break, we'll continue with functions and we'll go into calculus. Right. So let's clear the board. Let's clear the board. Please take this down and learn this. You need to understand these log laws. Right? In fact, before we start with that, let's just go through some of the log laws for you to make you understand what's happening. Okay. I want you to remember, this is important notes for you. Remember. Okay. Log of any number to its own base is always equal to 1. Make a note of this. Log of any number to its own base. So log 2 to base 2, log 5 to base 5, or log 10. Remember, log 10, if there isn't a base there, we can assume that there is a 10. So log 10 to base 10 is also equal to 1. You can't have log of a negative number. You can't have log of a negative number. You can't have that. Because your log graphs is always on the positive side of your x-axis. Remember, your positive log graph comes like that. Your negative log graph comes like that. Nothing happens on the negative side. So that doesn't exist. So that's your first log law. Your second log of 1 is equal to 0. Learn this. I want you to learn. These are added tips for you for the exams. Why is log 1 0? Why is log 1? Because isn't it your log graph, when it cuts on your x-axis, that point is what? 1 and 0, isn't it? So log of 1, what's the function value? 0. Log of 1 is 0. Right. I want you to remember this also. Pay attention. If I told you log 2, 3 plus log 2, 6. When you're adding and the bases are the same, this is the inverse of exponents. So in exponents, when you multiplied and bases are the same, you added the powers. Here, when you're adding, you multiply. So this is equal to log 2, 3 times 6, which is equal to log 2. 3 times 6 is 18. So when you're adding and bases are the same, you multiply the logs. Do you guys know these laws? No, but they're good to know. These are your laws dealing with logs. So log 2, 3 plus log 2, 6 is equal to log 2, 3 times 6. I'll give you another example. And those of you who are going to be writing your NBTs, this is also asked. Sorry, in your NBTs heavily. So if I told you log 3, 5 plus log 3, 2, this is equal to log 3, 5 times 2. What is 5 times 2? 10. The next log law So when you're adding, you multiply. So what if I told you log 2, 8 minus log 2, 4? So when I subtract, what do you think? And the basis, the basis must be the same. So if you added, you multiplied. So if you subtract, what are you going to do? Good. So that's log 2, 8 over 4, which is equal to log 2. What is 8 divided by 4? 2. And log of any number to its own base is how much? There we go. Good to know. Good to know. I'll do another example of this when you're subtracting. The bases must be the same. So if I told you log 3, 20 minus log 3, 4. Log 4 to base 3, log 20 to base 3. You're subtracting, the bases are the same. Log 3, 20 over 4. Log 3. What's 20 divided by 4? 5. Very good to know these laws, especially those of you who are going to be writing your NBTs later. NBTs are going to test you on these log laws heavily. Right, I'm going to show you another log law. Watch this. So, what log law is this? 4 or 5? What number are we on? 4, 5, 6. Which one? 5. Okay, here's another log law. If I told you log 2 over log 3 to base 10, this is the same as writing log 3, 2. Or the reverse of this is log 3, 2 or log 2 to base 3 is also equal to log 2 over log 3 to base 10. Right? Log 2, so both ways. Log 2 over log 3 is equal to log 2 to base 3. Or log 2 over 3 is also log 2 over log 3 to base 10. So it's the same. Working both ways. Just to show you here. That or the reverse. And the last log law. The last log law. That log 2 to base 3 can also be written as 1 over log 3 to base 2. You can swap these two over, but you've got to make it 1 over it. If you want to bring this one to a base 2. If you want to swap these two around, log 2 to base 3 is also 1 over log 3 to base 2. So learn the log laws. They're extremely helpful. And we are into break. Guys, we're going to go into break now. I hope you guys enjoyed the first session. I hope you learned a lot. Are you sure? You say yes, and then when you write the exam and I say, did you all pass? No. All right, I'll see you guys. 11 o'clock, we start with functions. Functions at 11 o'clock. We got a 30-minute break. Guys, enjoy your break.
And that's it from Al Falah College. We are now going for break time. Then we'll return after 30 minutes. And we say shukran very much. Thank you very much to Mr. Kota for facilitating that first session. If you have just joined us, we are doing the Awqaf SA Pure Maths Paper 1. And tomorrow you can also join us. We will be doing the Awqaf Pure Maths Paper 2. But if you would like to donate, we've got a lot of these programs. You can scan on the QR code that is currently on your screen now, and make sure that you support our programs, because as you know that Awqaf SA prioritizes these programs of this sort. You need to try by all means and ensure that you support the work fund as well. And that's it from us. We will be back at 11 o'clock, whereby we will be taking session 2 of the Awqaf SA Pure Maths exam preparation Maths Paper 1. Yes, Mr. Kota.
Okay. We are about to resume. Let's go. Khalid, how are we doing it? Let's keep all our comments coming in there on the side. Keep our live comments coming in, our live feeds. South Africa, how are we doing? Gauteng, Sindle. Welcome. Amina Ghani, welcome. Kaylan, welcome. Okay, so we did a very informative, very detailed algebra session for session number 1. And those of you who missed it and those of you who have just joined us now online, remember that these sessions are not only streamed on YouTube, but it's saved on our YouTube channel, on the Awqaf SA website. So you can go through these sessions if you missed anything after post-session and make sure that you master all the content. Okay, so let's see, are we all ready? South Africa, are we ready? We are now going into functions. I know this here is your nemesis. This is your Moses. Let's go into functions. Okay, so let's get started, guys. I hope you guys enjoyed the break. You are recharged, you are refueled. I'm clearing the frame. We actually went into all these log laws in detail before the break. Please remember to master this. Sometimes these log laws are not asked of you directly, but indirectly in NSC. But definitely will be asked for those of you who will be writing the NBT exams for university entrance later on in the year. So guys, I hope you took this down. We're clearing the board. And let's get started. Okay, guys. Sorry. Got a bit of a flu. Right, let's go. Right, I'm taking one out of a past paper. This is not out of the prelim paper of Gauteng's, this year's prelim paper. This is, I think, out of Free State. So they give you a parabola. Take this parabola down. They give you a parabola and they give you a straight line going through it. They call this graph F and they call that graph G. That's your x-axis, that's 0. That's your y-axis. Thank you. Let's go. The sketch shows the graphs of function f of x is equal to minus x squared minus x minus 12. And they tell you that g of x is x plus 4. Right, let's answer questions based on this. Guys, I can't understand why functions beat you because you've been doing this from the beginning of grade 11. The only introduction to functions for grade 12 is your inverse function and the log graph. That's all. Everything else is all grade 11 work. So let's get started. The first question, determine the x coordinates of A and B. So let's see, where is A? They call that point A. They call that point B. They call this point T, where the two meet. And they call that point C, and I'm sure C must be the turning point of the graph. Okay. There we go. A and B are the x-intercepts of f, while C is the turning point. The functions intersect at A, and they intersect at T. Right. Question number 1. The x-coordinates of A and B. Right. They want the x-coordinates of A and B. Okay, let's see our onliners. Are we all ready? Everybody all in? Yes, please pose your questions in the comment section from across the country. And yeah, let's activate and let's get full marks for functions. Remember, I'm starting off with the easy stuff. The easy stuff is the parabola in the straight line. We're still going to be doing the hyperbola with the shift in asymptotes, exponential, and the inverse of the parabola. We're getting to that. But please, guys, this is a section that you need to score full marks in. Now, The x coordinates of A and B. How do we find x coordinates? Let y equal to 0, yes or no? So now we're going to go minus x squared minus x minus 12 is equal to 0. Straightforward factorization, quadratic equation. We divide by negative, we left with x squared plus x plus 12 is equal to 0. We divide by negative 1, yes or no? Correct. Now let's break this up. So this was minus x plus 12, sorry. That was minus x plus 12. That was minus x plus 12. So that becomes negative 12. Right, so let's break that up. So that becomes that, here we go, is equal to 0. I just want to double check. Minus x squared minus x plus 12, that's correct. Minus x squared minus x plus 12. X squared, negative becomes a positive, negative becomes a positive, positive becomes a negative. We know we right. X, 4 and 3, plus, minus. X is equal to plus 4 or x is equal to negative 4 or x is equal to positive 3. So my x coordinates of A and B, so A's coordinates is minus 4 and 0, and B's coordinates is 3 and 0. So that's negative 4 and 0 and 3 and 0. There we go. Don't just leave it as x minus 4, x plus 3. Put it in coordinate form because that's what the question asks you for the x coordinates of A and B. What if they ask you the distance between A and B? What would the length of AB be? 7. Very good. Because distance can't be negative. Yes or no? 4 plus 3 would be 7. Okay. What is the range of f of x? Now, what does range refer to? Question number 2. Question number 2, they want the range of f of x. Now, we know the range is the y value of your turning point. Yes or no? Right? I'm just going to put there, it's the y value of your turning point. How do we get the y value of your turning point? Now, I'm going to show you. You guys use different methods at school. I'm going to show you what method I use. Right? Sorry about that. So that was x squared. F of x was equal to minus x squared plus, what was it? Minus x, né? Minus x plus 12. Yeah, there we go. Okay. We're answering question number 2. The range of f of x. I'm going to use this formula. I don't know whether you guys use the same formula. I'm just going to say 4ac minus b squared over 4a. Do you know this formula? How many of you don't know this formula? Right, you've never seen this formula. You know there's a x. Look. For the x value of your turning point, you can use minus b over 2a. Yes or no? And to get the y value of your turning point, you can use 4ac minus b squared over 4a. You can. Normally what you guys would do, you'd say minus b over 2a to get x. You put it back into the original to get the y. You could do that, no problem. I just use this formula to get the range. That gives me the range. Right. So 4a is minus 1, c is 12, minus b squared minus 1 squared over 4a. And that would give me minus 48 minus 1 is minus 49 over minus 4, which is equal to 49 over 4. And there we go. 49 over 4 is the y value, and it's all your y values less than. So the range is, therefore your range is going to equal to, your range is going to be from negative infinity up to 49 over 4. and it's equal to, or you can say y less than or equal to 49 over 4. Y is an element of real numbers. There are two ways in which you can write it. You can write it in interval notation, or you can write it in inequality form. Both of them, you'll get it right in your exams. So now many of you have learned a new formula for the range of a parabola. 4ac minus b squared over 4a. You don't need to do the x value first, and then it just saves you time. If there's a value for x, there must be a formula for x. There must be a formula for y. Correct. Onliners, how are we doing? How are we doing? Good, 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 good. Let's go. Right. Let's look at the next question, guys. Find the maximum value. Now check this one out. Check this next question out. So we're doing question number 3 now. Question number 3. Find the maximum value of f of x is equal to 3 to the power f of x minus 12. Find the maximum value of this. Right. How would we answer a question like this if it was worth 3 to 4 marks? Come grade 12s. These are the ones that I know beat you in the exam. They're not difficult. I promise you, you just need to understand what they are saying. What are the crucial words here? Maximum, and whenever they say maximum value, what are they talking about? Maximum y value. Yes or no? Now pay attention. This is how we do it. Find the maximum value. Now this could be worth 3 to 4 marks. It's marks you don't want to throw away in your exam. So now we know that f of x is equal to 3. What is f of x? What is f of x? Minus x squared minus x plus 12 minus 12. Yes or no? Now, what was the maximum value of this? We just found that out in the previous one. So it's 3 to the power, what was that? 49 over 4. Remember, the maximum value of that was 49 over 4 from our previous one. Minus 12, which is equal to 3 to the power. What is 49 over 4 minus 12? Go to your calculator. Say 49 over 4 minus 12. I get a quarter. Yes or no? Now, what is 3 to the power a quarter? 3 to the power 0.25. 1,316, 1,32. That's your final answer. You'll get 3 to 4 marks for that. This was your maximum value. This 49 over 4 was the maximum value of that. But now you had to include the minus 12. So it's 3 to the power a quarter, and your final answer is 1,32. Learn this. Learn. They love these questions. They love these questions. You know it's coming out. You know it's coming out. Now the next one. Now the next one's quite interesting. The next one is quite interesting. Now, what if they ask you for 3, they ask you an inequality with 3x values like this. Watch the next question. What question is it? Say question number 3. Question number 4. Let's say question number 4. Come on. Onliners, how are we doing? How are we doing there? Khalid, keep our comments coming in there. There we go. There we go. There we go. By mode 5.3 max value. Yes, you'll still get your marks. No problem. No problem. Yes, you must add. Y is the element of real numbers. Okay, now watch here. Watch this. Question number 4. For which value or values of x, for which, take this question down. For which value or values of x is, let's say, x times f of x less than or equal to 0 for 4 marks. Now, they're not saying g of x. They could, if they wanted to, they could say g of x times f of x, or they could say x times f of x. How many of you know how to do this one? Here, they're not saying g of x times f of x. Here, they are saying x times f of x. Now, there are many ways to do it. Your memo, the memo for this only gives you the final answer, so you would never know how they got it. That's what I'm here to do, to show you how it's done. Right, pay attention. Put your pens down. So here's my x. That's my question. Here's my answer. This is the way I would do it in the exam. Watch here. Here's x, right? I'm putting x there. There's x, there's x. Times f of x. Times minus x squared minus x plus 12 less than or equal to 0. Yes or no? I'm putting a tick. Do you all understand that? Now pay attention here. Pay attention. So that means I got x, and if I factorize that, less than or equal to 0, right? Okay, if we took out the negative here, in fact, let's do this. Let's do this. Let's take out the negative first, right? Let's take out the negative. Then I'm going to be left with x squared plus x minus 12 less than or equal to 0. Yes or no? Okay. Now we're going to go minus x, and I'm going to break this one up. And if I factorize this, what would I get here? I'd get x, 4, and 3, plus and minus. Yes or no? Now I'm going to get rid of that negative sign. So I'm going to divide by negative. I'm going to divide by negative. So I'm left with x plus 4, x minus 3, greater than or equal to 0. Why? Because I divided by a... Are you guys all with me? Now pay attention. Here's the trick. Here's the magic happens now. You want to see the magic now? Right, here's the magic. What are your critical values? X equal to 0. So watch here. So x is, I'm just going to write it here on the side. X is equal to 0. X is equal to minus 4. Or x is equal to plus 3. Yes or no? Now watch here. Here's the magic. We do that. It's 3x values. So we don't draw a parabola. What do we draw? A cubic graph. Right? A rough cubic graph. 0 is in the middle. Minus 4 is here. And 3 is there. Greater than or equal to 0 means where is this graph above? So where is this graph above your x-axis? It's above there. And it's above there. Yes or no? So we put an x here, and you got an x there. So now, here's your first answer to all the values to the right. X greater than or equal to 3, or between these two values here, x 0 minus 4, between the two, less than or equal to less than or equal to. And there we go. That is your answer for that question, where it is, where x times x. So whenever you have three x values, you don't draw a parabola. What do you draw? A cubic graph. Are you listening to me? You draw a rough cubic graph. And this is how you solve for the three x values here. Greater than or equal to 0. Where is this graph above? It's above for all your x values to the right, or it's above between these two values. So there's your answer. Now, your memo only gives you your final answer. Your memo only gives you your final answer. You would never get it right. You never understand how they got to it. I'm showing you how you get. You can answer it in your paper exactly the way I've done it here on the screen. Does it make sense to you? Right, take this one down. I'll do another one like this for you. We'll see whether you can do one like this by yourself. With three x values. Right, so you've taken this, you're busy taking this one down. Let me give you another one to do here. Those of you who have taken this one down already. I'm just giving you an example here. If I told you x minus 2, x plus 5, x minus 1, less than or equal to 0. Right, question. Solve for x. Solve for x with these three x values. Solve for x. How are we doing, onliners? How are we doing, onliners? Are you learning? I hope you're learning. What if you don't factorize and have a cubic equation? How would you find those x values? You can actually find the x values using your FX, your calculator. You can factorize using your Casio FX 991 plus, the one that says factorize. Right, those of you who are done taking the previous one down, do this one here, x minus 2, x plus 5, x minus 1. Just to test whether you understand the concept. Put your critical values down. What are your critical values? X is equal to 2, x is equal to minus 5, or x is equal to? Yeah, good. And now what do? We draw a rough cubic graph, yes or no? Right. So now what do we have? We got minus 5 there. We got 1 there. We got 2 there. Yes or no? Less than 0. Above or below? I can't hear you. Below. So where is this graph below? Where is this graph below? It's below here. And it's below there. Yes or no? So x less than or equal to minus 5, or between these 2 points, x, 2, 1, and it's between the 2 points. There we go, and you can just say x is an element of real numbers. There we go. That's how you'd solve for x in a cubic if you got three x values. Does it make sense to you? It should. Right. Right. I'm gonna twist this a little bit. I'm gonna ask you some questions, some exam questions. Just playing around with this to see that you understand all the concepts with regard to this. Right, so that was your question there. Let's do another question. for which value of values of x, for which value of values of x will f of x and g of x plus k, or for which values of k, sorry, for which values of k, for which values of k will f of x and g of x plus k have unequal roots. Right. So here goes, guys. For which value or values of k will f of x and g of x plus k have two unequal roots? Now they're talking about nature of roots, yes or no? So what must I do to these two? I need to equate them and apply delta, yes or no? So now I'm going to say f of x equal g of x plus k. So f of x is minus x squared minus x plus 12 is equal to g of x, which is x plus 4 plus k. Yes or no? G of x is x plus 4. There we go. Plus k. Now, minus x squared minus x plus 12 minus x minus 4 minus k equals 0. So minus x squared minus x is minus 2x. 12 minus 4 is 8. Minus k is equal to 0. Now we can apply delta, yes or no? Delta is equal to b squared minus 4ac, because they're talking about nature of. So delta is equal to what's b squared? Minus 2 squared minus 4. A is how much? Minus 1. C is how much? 8 minus k. Please don't mess this up. Now comes the algebra. Don't mess your algebra up here. So minus 2 squared is 4. That you multiply will give me plus 4 into 8 minus k. So delta is equal to 4 plus 8 times 4 is 32 minus 4k. So delta is equal to 36 minus 4k. Yes or no? That's what delta is. For unequal roots, what do we know? Delta must be what? I can't hear you. Greater than 0, not equal to. Not equal to. So now you go back. Now you say for unequal roots, for unequal roots, what do we know about delta? Delta must be greater than 0, yes or no? 36 minus 4k greater than 0, because that was delta. Now solve for k. Now solve for k. So obviously, what are you going to have? Minus 4k greater than minus 36. You're dividing by a negative. So k less than. Negative divided by negative is a positive. 36 divided by 4 is 9. And there we go for k less than 9. Yes or no, guys? Okay, good. Onliners, you following? Khalid, how's it coming in? How's our onliners doing? Are they matching? Which comment was that? How do you know that's the shape of your graph? Your shape of your graph is always cubic. For 3x values, it's always cubic. 3x values, it's cubic. 2x, you know, 1x value, it's a straight line. 2x values, it's a parabola. 3x values is what? A cubic. Okay. So here we go, guys. Right, now pay attention. Now we're going to be talking about the inverse of the parabola. Very important. And I told you people in our previous workshops as well, this style is coming out. Now, very important. Can I erase here? Okay. Now, if they told you to sketch the graph f of x is equal to 2x squared for x greater than or equal to 0. Right. Let's say they asked you to sketch this. Question number 1, sketch. Question number 2, find the inverse. With restrictions, f of minus 1. Right. Very important. Now, let's answer question number 1. It's a straightforward parabola. So, I'm just putting dotted lines here because I'm going to erase half of it. There we go. There's your 2x squared graph. Graph F. But they give you a restriction for x greater. That means they only want the positive part of the graph. That means you've got to erase all of that. Do you guys understand? Grade 12s. There we go. That's for x greater than or equal to 0. Yes or no? Now they want you to give the inverse. Give the inverse and sketch. I'll show you why this is important. Because in the Gauteng paper, they didn't give you the forward. They gave you the reverse. They gave you the diagram you needed to give the equation. So you need to know forward and reverse. So now, pay attention to me, guys. We know, listen, we know that that's your f of x. It's pointing to the positive y. That means the inverse of the graph must point to the positive x. Yes or no? But they only want for x greater than or equal to 0. So they want the positive part of the graph. That means we need to erase the negative part of the graph. Does that make sense to you? Because it has a restriction. So if this is graph F, that means this graph is f of minus 1. Yes or no? Is f of minus 1 a function? Is f of minus 1 in this case a function? Who says yes? Who says no? Who says no? It's a function. Of course it's a function. It's a one-to-one relation. Only if the graph went like that and you got one x value and you got two y values, then it's a relation. Then it's not a function. But in this case, is f of minus 1 a function? Yes, it is. Why is it a function? Because it's a one-to-one relation. For one x value, there's only one y value. This is not a function. That's not a function. Because one x value, you got two y values. That's not a function. This is a function because it's one-to-one. It's a function with a restriction. Guys, are you following? Good. Now, how do we write the inverse of this? They want the inverse of that. Now, you guys do many ways at school, right? You know y is equal to 2x squared. So f of minus 1x is equal to, Normally, we'll put plus minus the square root of, if this is 2 over 1, this would be 1 over 2x. But they say for x greater than or equal to 0, so you take the negative sign away from the outside. This sign outside indicates the restriction from original. Take a note of all of this. This is very, very important. You'll see when I do the one from the past paper after this, how all of this is going to all tie up. And this sign inside tells me whether the original graph, the positive or negative inside or underneath the third side, tells me whether the original is a positive or a negative graph. So, very important, the sign outside, the third sign, and the sign inside tell me two totally different things. The sign outside tells me the restriction. X greater than or equal to 0 or x less than or equal to 0. The side inside, underneath the third sign. What does that tell me? Whether my original graph was positive or negative. So you can swap the x and y and make y the subject of the formula, no problem. So even if I told you, let's just give you another graph. Let's say g of x was equal to minus 3x squared. For x less than or equal to 0. Let's see if you guys can do this one. Sketch this one. Sketch this one. I want the inverse equation and sketch the inverse. The inverse equation and sketch. Guys, this problem must be done in 10 seconds. If you're taking longer than 10 seconds in your exam, it means you don't know your work. Let's go, guys. Right. Just to show you how quick this is done. So there we go. It's a negative parabola. But they only want for x less than or equal to 0, so I erase it. That was done in 3 seconds. Right. Now give me the inverse equation. So g of minus 1x is equal to, for x less than or equal to 0, minus the square root of minus 3 over 1 is 1 over 3x for x less than or equal to 0. There we go. That's your equation. That minus was my restriction. And this minus, my original was negative. So there we go. You're going to get a mark, or you'll get 2 marks for that. Are you guys following me? Right. Now sketch the inverse. Now you know that the entire negative inverse will go like that. But they only want the negative part of the inverse. So there we go. So this is graph G. This is the graph G of minus 1. And there we go. You're going to get full marks for that. Easy peasy. Easy peasy. Now let's have fun. Let's take the one out of Gauteng's prelim paper. Now they're not asking you to sketch. Now they give you the graph. You need to work out the reverse. No stress. I will not stress. I will not stress. If you guys listen to me and you understand what I'm saying, you will love it, you will look forward to it, you will hope it comes out in your exams. Okay, so here goes. Shh. You ready? Are you ready, guys? For the one from the exams. All right, while you guys are taking that one, those of you who are done already, you can take from the the Gauteng prelim paper. And this is how you can score full marks. I'm showing you the methods. Now that the question is given in the exam, we're going to fly through it. We're going to get full marks. The question that was given in the exam, check here. Come on. There's it. Isn't it the same graph as this graph G that we just did? Right. But only thing they give you a point on the graph P, -6 and -8. Come on. Guys, we already know that this is graph F, and F of X is equal to, they tell us, AX squared for X less than or equal to 0. We know that it's a parabola. It's half a parabola. Right. Let's go. Let's answer the questions on this. Let's answer the questions. Come, grade 12s. Come. This is where you score full marks. This is where you score full marks. Right, question number 1, they want the value of A. I'm telling you, most of the learners got this wrong. I can't understand why. If you just had to understand what we've done in all the workshops and mastered what I'm teaching you, you'll get full marks in your exam. Right, now they want the equation of F of -1. Question number 3, they want the range of F of -1. Sketch F of -1. Come on, these are marks for gem. Right. Then they say it's reflected about, they say, the graph of F is reflected across the line y equal x. If F is reflected about the line y equal x, and thereafter reflected again across the x-axis, and thereafter about the x-axis, give the new equation. Come on, guys, this is marks for gem. I promise you this was 9 marks. So after your parabola and your straight line, which was 15, another 9, that was 34. Then we're going to do the hyperbola with the shift in asymptotes. Then we're going to do the exponential and log. Come on, there's the total marks here, guys. Total marks for functions. And then we start with our favorite topic, calculus, which we love so much. Right, come on. This 9 marks can be answered in probably 2 minutes. It's so simple. Right, the value of A. So y equals ax squared. Come on, they give you x, they give you y. So -8 is equal to a x minus 6 squared. -8 is equal to a into 36. Yes or no? 36a is equal to -8. A equals -8 over 36. A equals minus 4 goes into there, 2 times, 4 goes into there, 9 times. What is A? -2 over 9. Was that difficult? There's your first marks. Go back to your original equation and change it. And you know you're right. Why? Because it's a negative graph. Oh. Right, guys? You got that? Done. Value of A. Right, give me F of -1. Let's do it together. Watch here. Watch how easy number 2 is done. Check here. Without even doing the whole story, I'm going into question number 2. F of -1x is equal to, because I got a restriction, it's minus the square root of -9 over 2x for x less than or equal to 0. Finish. How long did it take? 5 seconds. And you guys spend 1 hour in the exam trying to figure it out. 5 seconds. The range of f of minus 1. Now this is interesting. So now we need to understand, what does f of minus 1 refer to here? F of minus 1, what does f of minus 1 look like? Now this is the negative part of the negative graph. So the negative part, that's f of minus 1. What's the range of this graph? I'm answering question number 3. The red graph, f of minus 1's range. Y less than or equal to 0. Y is an element of real numbers. Or you can say from minus infinity up to 0. You can give the answer like that or the answer like this. Sketch f of minus 1. There, we've done it already. Now let's do number 4. Onliners, how are we doing? Tell me you are mathsing, you are smashing math. You're getting them all right. Samad, Lamini, you're getting it all right. Easy. Mr. Solomon. Nice. Severe gamers. This is severe math in severe KZN. Excellent. The parabola is always at the origin. Okay, good question. Why is the parabola always at the origin? Because your Q value here is how much? 0. Your parabola for ax squared is always at 0 because that's your y-intercept. Let's answer question number 4. If f, now, y equals minus 2 over 9x squared. If it's reflected about the line y equal x, that means the 2 must swap over. So x squared is equal to minus 2 over 9. It's reflected about the line y equal x. So that means that's, let me just go back. It's reflected about the line y equal x. So that means that was the inverse, right? What was our inverse? Y equals minus the square root of minus 9 over 2x. That is about the line y equal x, the inverse. And now about the x-axis. So when you reflect something about the x-axis, what happens? The y sign changes, yes or no? So now you'll have minus y is equal to minus the square root of minus 9 over 2x. In your final answer, can y ever be negative? So we divide by negative, we divide by negative. Here's your final answer coming up. Y equals the square root of minus 9 over 2x. Because when you reflect something about the y-axis, the x-axis, the y sign changes. Now, very important, something now I need to, before we go on to the exponential and the log. Many of you don't know your rules of rotation. They asked about rotation. Now, you know, rotation rules, they dropped out of the syllabus years ago. But it's coming back in. So they're not only asking about reflection rules, they're also asking about rotational rules. How many of you remember your rotational rules, grade 12? So few of you, and you're writing final exams. It means you didn't even learn rotational rules for June or for prelims. Let me give you your rules quickly. Let me give you, remember, I'm here to make sure that you have every single tool. So there's nothing that they can ask you in the exam that we haven't done in this workshop. That's the importance of today and tomorrow. You will see tomorrow when we do Euclidean and Triggs. Yeah, that paper 2. It was a walk in the park if you had to just follow what we did or what we always do. You follow the laws. I'm telling you, it was you could fly, you could ace that paper. Okay, let's go to the rotational rules, guys. Right, let's first go to the rules of reflection, quickly. When you reflect something about the x-axis, what happens? The y sign changes. When you reflect something about the y-axis, what happens? X sign changes. Yes or no? When you reflect something about the line y equal x, the two swap over, the x becomes y and y becomes x, and the signs don't change. Don't change. And this is also the inverse. So another word for the inverse of something about the line y equal x is a reflection of about the line y equal x. So there we go. The x-axis, y-axis, line y equal x. Now let's go to rotation. Now you get 90 degrees anti-clockwise, 90 degrees clockwise. Then you get 180 degrees anti-clockwise, and then 180 degrees clockwise. Please learn it in this order. So let's take a point, any point. Let's take a point P2 and 5. Any point. They want you to rotate this 90 degrees anti-clockwise. So 90 anti, P dash. The two swap over, 5 and 2. And the X sign changes. That's why I put anti first and then clock. Because the X sign changes, Y sign changes. So you swap and the X sign changes. For clockwise, the two swap over, the Y sign changes. Can you guys see that? Grade 12s. Please learn. (180 anti, 180 clock). Doesn't make a difference. They're the same. P dash. They stay in the same position, 2 and 5. We take in the original point. And both signs change. They stay in the same position. Stay in same position. But both signs change. There we go. Here they swap over and the X sign changes. Here they swap over and the Y sign changes. Here they stay in the same position, but both signs change. So learn rotation. So we got our rules of reflection. We got our rules of rotation. Onliners, are we okay? I hope you're remembering this. I hope you're taking it down. You're circling it. You're memorizing it. Thank you, Cassidy. Please learn. I beg you guys, learn. Going well. Miss Fredericks. What a lovely name, Tobisi. Please, I beg you guys, learn. Right, now watch. We're back. We're still in the exam, eh? I'm telling you, we are sitting in, as we sit in this workshop, we're sitting in the final exams. I'm clearing the frame. Again, I'm telling you, those of you who have just joined, if you missed anything or if you feel like something went a little too fast, after the session, it's on YouTube. Go back, master, memorize today and tomorrow. You're going to see tomorrow when we hit that compound and double angles, how we're going to fly through maths. And I know I had learners who scored 149 out of 150 for paper 1. How much? 149. And dropped to 105 for paper 2. Drop down to 67 just because of paper 2. So guys, don't fly high. You need to make sure that you are polished completely paper 1 and 2 today and tomorrow. You can get an A for paper 1 and you can fail paper 2 nicely, beautifully. Guys, don't mess up tomorrow's paper. I beg you. Right, here goes. Take this one down. The fun is starting. We're doing the exponential and log now. Right, here goes. This is from Gauteng's paper. Gauteng Prelim, 2024. That point is point Q. They give you a point here, A, minus 1.5. Right. Besides the questions that they gave here, I'm going to add on as many questions as I can so that there can be nothing that they can ask you that will beat you. Right. Right, now listen to this. Listen to this. Grade 12s. Do you know what was the first question here? Listen. The point P, 2 and 3. I just want to show you something. They tell you the point P, 2 and square root 3. Pay attention. Lies on a Cartesian plane. Determine the coordinates of the image of P if P is rotated about the origin 90 degrees in the anti-clockwise. They're asking you for 90 degrees anti-clockwise. Didn't we just do that? That was the first 2 marks. So let's answer that. Come on. 90 anti. P dash. The image of this. The 2 swap over. Root 3 and 2. The X sign changes. And if you didn't do that, you would have lost your first 2 marks. Just because you didn't learn the rotational rules. Okay, next question. Why are the coordinates of Q, the y-intercept 0 and 1? Why? So they're telling you that the coordinates of Q is 0 and 1. We know that. They're asking you why. Why is it 0 and 1? Because in an exponential graph, if I told you this, watch this. If I told you, let's say this was grade, this is graph H. If I told you H of X is equal to 2 to the power X, any base to, so how would you answer this? You can answer it in English. What makes sense to you? Whenever X is 0, any base to the power 0 is how much? 1. So you can say all standard exponential graphs have only one y-intercept, 0 and 1. And why would that be? That's one answer that you could possibly give. The second, or you could say, what else could you say? In an exponential function, in any standard, that's a standard exponential function, whenever x is 0, whenever x equals 0, the function value will always be 1. Because any base to the power 0 will be 1. Yes or no? So there's 2 possible answers for that question. Why is Q 0 and 1? Right, calculate. Now they tell you h of x is equal to a to the power x in this case. Find the value of a. Right, you guys work it out. Find the value of a. Find the value of a. And I'm going to add on many more questions to this. Oh, and then they give us, the, beautiful. Right, let's go. Let's find the value of a. Come on, guys. This is easy work. This is marks for jam. Right, question number 2, they want the value of A. Right, the value of A, y equals A to the x. There's x, there's y. Do not use that point. You use another coordinate. A half is equal to A to the minus 1. Many of you didn't know. I promise you, this year shocked the life out of me while I was marking matric papers. That many of you didn't know how to solve for A here. Really? You in grade 12, you don't know how to solve for A there? Don't write your finals. Leave school now. Quit. Quit. Serious. Dr. Singh, if at this point of the year they don't know how to solve for A in that equation, what should they be doing right now? Leaving. Leave school. Leave the system. Right now, what here? 1 over 2 is equal to A to the minus 1 is 1 over A. Now, flip this side, flip that side. A is equal to 2. Yes or no? So h of x is equal to 2 to the power x. I told you this is the most commonly asked graph. You must just learn listen to me, grade 12s. If you really want to master this, just learn 2 to the x, half to the x, 3 to the x, quarter to the x. Those are the most, 3 to the x or 1 over 9 to the power x. Those are the most commonly, I mean, come on, these numbers are small. They asked all over. This is your bread and butter questions, man. Seriously, if you guys can't do this, you are in big trouble in your exams. Right, now they want the equation of h. Obviously, you know what's the next question. They want h of minus 1. This is your jam questions. If you can't answer this, don't write your maths paper, man. They want h of minus 1, x. So it's the inverse of this. So h of minus 1x is equal to log base 2 x. Some of you in the exam went to write log x squared. Some of you went to go and write log x2. I don't know what crap. Honestly, I don't know what crap you guys write in the exam. You write your own rubbish, whatever comes to your head, you think, okay, you know what, it might be right, let me just put it. It just shows you haven't studied. You didn't open up your books. You weren't at school this year. Where the hell were you? Where were you? Seriously, where the hell were you the whole year? If you can't write log 2x, where were you? Vavas J. You're making me sweat here, bruh. You know, as a matric, as a marker, as an examiner, as a teacher, as a facilitator, these things can make you blow a gasket. Serious. You guys can give a teacher a heart attack, especially when marking your papers. It's like, were you in school this year, dude? Right, let's go. Right, now sketch this graph. The next question, sketch the graph. Again, where were you at school? They ask you to sketch this graph. Yeah, the crap that some of you drew. Some of you drew a graph going like that. Some of you drew a graph going like that. Some of you drew a graph going like that. Are you on drugs? Where were you? Vavas J. The inverse of a positive exponential is a positive log. If you draw anything besides that, you will fail. Some of you in the exams went and did that. What the hell is that? From which planet does that graph? Does it even exist here? about you. Woo! Stress, bruh. Grade 12s give me stress. What is this point? What is that point? If this point is 0 and 1, what the hell must this point be? And if that point is -1.5, where must the other point be? A half and -1. Yes, a dash, a half and -1. The inverse, you swap the damn two around. They've been telling you that the whole year. You still went to go and write your own crap in the exam. I promise you, your answers came from Jupiter. They came from Mars. They came from Uranus. Other planet answers. Astaghfirullah. Right. Now the next question. I will die doing maths, bruh. One day I'll just get a heart attack here, just here. Because somebody will give some stupid answer. Right. Where is h of -1x greater than or equal to 0? Onliners, how are we doing there? Khalid, how are we doing there? Our onliners also sweating like us. Also giving stupid answers. Shift solve. Yeah, very nice, Angel. Shift solve. Solves all problems in this world. Come, guys. Come, guys. Yes. Now, that means where is your log graph? How would you interpret this? Where is your log graph positive? That's what it means in English. For those of you who don't understand English. I'm just saying, for those who don't understand English. No, there's a lot. There's a lot. There's a lot. Trust me. Everywhere. Everywhere. English is a big problem. Where is your log graph positive? So where is this graph positive? It's positive there. So your answer would be for x greater than or equal to 1. For all your x values greater than or equal. And if they ask you where is h of -1x less than or equal to 0, then it would be between these 2 points here. Between 1 and 0. For x less than or equal to 1 but greater than 0. You can't put the equal to sign there. Why? Because 0 is what? What is 0? Sorry? What is that line? What is your y-axis in this graph called? Your asymptote. And what is the equation of your asymptote for your log graph? X equals, I still see, I hear y equals 0. That's why you will fail. Okay? That's why you will fail. You must say, in the exams for the y-axis, you must say, the equation of the y-axis is y equals 0. Then when you get Olympic rings in your report, you must not ask why. You mustn't say Marawai. Right. What is the domain and what is the range? What's the domain of this graph? What is the domain of the log graph? So let's say, what is the domain of h of -1 and what is the range of h of -1? You guys still in grade 12 and you still don't know what is domain and range. Brilliant. Dr. Singh, in grade 12, they don't know domain and range. Domain is your x values. Which are your x values? X greater than 0. X is an element of real numbers. Or 0 to positive infinity. You can't put included, you can't put an equal to sign. Some of you are so negligent. You are so negligent in the exam. Be very careful when you're introducing an equal to. Ask yourself, is that value included or excluded? Excluded, no equal to sign. Included, equal to sign. What is the range? Y is an element of real numbers. Or you can say from negative infinity to positive infinity. You never put, some of you put an infinity and you put a square bracket. On which planet? How can you have a square including infinity? Infinity goes on forever. How the hell can you have an included sign? Okay. And that brings us to the end of the log graph. Now, I think in your final exam, let's go. H of x is equal to log of a third x. Sketch that graph. And then give me the inverse function. And then sketch the inverse. Right, let's do it quickly. Come on, this is not rocket science. I don't want to spend the whole day on this. How's our time, Praz? Owens? You're 10 past 12 already. Right, watch here. So here goes. Log of a third x. The graph goes in that direction. It also goes through this point here, 1 and 0. And that is graph H. That's your negative log graph. Negative log graph. There we sketched it. What's h of minus 1? The inverse of this is a third, your base. A third to the power x, or you can say 3 to the minus x. No problem. Sketch that graph. That graph goes in that direction, going through 0 and 1. That's it. Let's go into the hyperbola with a shift in asymptotes. The graph that they gave you here okay. This is where we're wrapping up. We are wrapping up now. We are wrapping up with the hyperbola. So we did the parabola, we did the straight line. We did the exponential, we did the log. We did the positive exponential, negative exponential. Positive log, negative log. We did the, we did a lot of work. We even did the parabola with a restriction and the inverse of the parabola with a restriction. Yes or no? Right. Let's go. Now, again, I'm telling you, I'm taking Gauteng's prelim paper. You see how we're answering it. We're flying through the paper. We're getting them all right. By now, we're already sitting on 80% for the paper. So far. How could you fail? That's how some of our learners got 149 out of 150. The one learner made one silly mistake. He forgot a negative sign. That's why we subtracted 1. Otherwise, he would have totaled the whole paper, 150 out of 150. And I promise you, you're not going to get another program like this in the country. So if you're not paying attention, you're not working with us now, you're not mastering it while we're here, you only got yourself to blame. Nah, yeah. Let's go. Right. So they tell you sketch below. Okay, they give you the graph. Take this one down. G of x is equal to 2 over x plus 1 plus 2. And they tell you that f of x is equal to minus x plus 4. Right. You know how simple they all, not only did they give you the equation, they even gave you the two graphs. They even sketched it for you. So they gave you a graph between 4 and 4. So take this down. They gave you a graph there. That was 4. That was 4. And then they gave you another graph. Going like that. And another graph coming like that. And this was point C. That was minus 2 and 0. And that was 0 and 4. And they gave you, that is point A. That's a 4. That was point A. And this here is point D. Right. Here's the question. Right. So this is given to you. In this case, you all know how to sketch. Let you put down your equations of your asymptotes. Let x equal to 0 solve for y. Let y equal to 0 solve for x. Question number 1. Domain of G. Seriously? What is the domain? Now your domain of a hyperbola with a shift in asymptotes is that x is an element of real numbers, but x cannot equal to your x asymptote. Am I right? Now what's your x asymptote? Minus 1. Yes or no? So you must, although it's not drawn in on your diagram, you must go and put it in, and you know that this value is negative 1 taken from your equation. And then although this value is not given on your diagram, you go and you put it in, and you know your y asymptote is 2. That's y equal 2. That's x equal minus 1. Yes or no? So what's your domain of G? Your domain of G is x is an element of real numbers, but x cannot equal to minus 1. Or you could have said minus infinity to positive infinity, but x not equal to minus 1. You must write your restriction in. Yes or no? Question number 2. The equations of your asymptotes. We've just done it. Equations of asymptotes. So obviously, what's the answer for that? X equal minus 1. Some of you went to go and write P equal minus 1. Who the hell told you to write P? Where's the P? Where did you get P from? Some of you just write minus 1. What is minus 1? My grandmother. An equation of an asymptote, x equal, y equal. They've been telling you this from the beginning of the year, but nothing went in. You just wrote whatever you wanted to in the exam. Every man for himself, God for all. There we go. Please, x equal minus 1, y equal 2. Right, calculate the coordinates of D, the point of intersection. I want you to do it. Again, algebra, grade 12s. If you can't do algebra, you will fail. Now, find me the coordinates of D, the point of intersection of the two graphs. And many couldn't do this. Seriously, I was just out of breath, out of words. Some people murder maths. What mathematicians and philosophers have done for thousands of years and millions of years, some matrix of 2024, stuff it up in 5 minutes. They make these mathematicians and Pythagoras turn in their grave. Poor guy spent his whole life trying to teach Pythagoras. Oh, our grade 12 still look at it. And instead of doing h squared equals, they're starting with x equals y equals r equals x minus y. Doing their own thing, they are jiving, they're doing breakdance. Now, honestly, if you cannot equate these two and solve, I don't even want to say that. I don't want to say. The point D is the point of intersection. Now, whoever cannot solve for x in this, please leave school. Serious. Get married, make babies. Serious. Get married, make babies, do what you want to, sit on the, go beg on the street, man. Really, if you can't solve this, you are a waste of genetics. Right, let's go. You know what? You are laughing. 70% of you here will not answer this. You will get it wrong. You will not solve for X. You will not solve for Y. 70%. Half of you will fail, I'm telling you. Okay, let's not be bad. Half of you won't fail. Two over x plus 1 is equal to minus x plus 4. The plus 2 will come on the other side as minus 2. Did you do that? You are lying. You just want to save yourself. Right. That's over 1. Cross multiply. Right. 2 times 1 is 2 is equal to x plus 1 into minus x plus 2. 2 equals minus x squared plus 2x minus x plus 2. 2 equals minus x squared plus x plus 2. X squared minus x minus 2 plus 2 equals 0. X squared minus x equals 0. X into x minus 1 equals 0. X equals 0 or x equal 1. How many of you got that one right? Welcome to 2024. And then what was your other equation was y was equal to y equals minus x plus 4. So now obviously the one was 1. So that means we had to only use 1. So y equals minus 1 plus 4. Y is equal to 3. So D's coordinates is 1 and 3. Yeah, boy, yes. Right. Now, just to wrap up before break, we got 5 minutes. We got 5 minutes before break. y equals x plus 1 over x minus 4. Rewrite that in the form a over x minus p plus q. And let me give you another one. Start with that one so long. Y equals minus 2x plus 5 over x minus 1. Rewrite both of them in this format and find the equations of the asymptotes. Right, this is question number 1. Question number 2, rewrite both of them in this form. And then question number 1, question number 1, rewrite both of them. Question number 2, I want the equations of the asymptotes. And question number 3, I want the equation of the axis of symmetry with m less than 0. The equation of the axis of symmetry for m less than 0 for both of them. Right. We don't have much time, guys. We've got like 3 minutes. How are we doing? How's our onliners doing there? Khalid. Khalid, how you got it? Well done. Well done, evidence. This is the last one, Salman, I think. Let's go, let's go, let's go. I hope you guys are enjoying it. Onliners. I think we're sitting on about 8,000 or 9,000 onliners. Logins. Oh, can somebody please give us a hug for me? Big hug. Group hug. Right, let's go. Let's wrap up before break. Right, watch here, guys. Let's answer question number 1. So y is equal to, you put x minus 4, you copy and paste it on the top. This is the way you do it. Take the denominator, put it on the top. We need to get plus 1. So minus 4 plus a certain number is equal to 1. So the certain number is equal to 1 plus 4. The certain number is equal to 5. Because we know minus 4 plus 5 will give me back 1. Now split it up. Y equals x minus 4 over x minus 4 plus, split it up, plus 5 over x minus 4. Your final answer, 5 over x minus 4. There we go. Plus 1. So x, your asymptotes, x is equal to 4, y is equal to 1. Yes or no? So there we go. We've rewritten that one. Now let's rewrite that one. Who remembers how to do that one? Nobody. You are in trouble. If they gave you this as a hyperbola with a shift in asymptotes and they asked you to rewrite it and sketch it, you'd fail. You'd get 0 for the whole question. Right, we're wrapping up now. We're going for break. We're going for lunch. I want to finish this one up first. Right, let me teach you how to do this one. Those of you who don't know how to do it or who's, I did this one in our last workshop, last grade 12 workshop. You probably might have missed it. But in any case, for those of you who are here, Please learn this one. It's good to know. This is also in NBT. They love asking this in, oh my word. Okay, there we go. Right, this is also asked in your NBTs. So those of you who are going to write, they love asking this question in your NBT because it's a hyperbola with a shift in asymptotes. Right, let me teach you how to do it for those of you who don't know. Learn these. These are tools. These are tools. Right, you know what you do here? Let me show you. Let me see from here. Show of hands. How many of you know how to do this one? Nobody. Nobody remembers. Nobody paid attention to our last workshop. Nobody has been watching the Awqaf workshop on. Watch what you do. You take it's that divided by that. So you say x minus 1 into minus 2x plus 5. I'm showing you how. This is how it's done. Pay attention. Now, x times what will give me minus 2x? Or minus 2x divided by x is how much? Guys, minus 2x divided by x is how much? Right. Now pay attention. Now you multiply it by each. Minus 2 times x is minus 2x. Minus 2 times minus 1 is how much? Plus 2. Now we subtract. So we change both the signs. That becomes plus. That becomes minus. 2x minus 2x is 0. 5 minus 2 is how much? 3. Here's your answer. Y equals. You take your remainder. Divide it by what you took out. By what's your divisor? Right? So it's x minus 1. And then whatever your quotient is there on the top, minus 2. There's your answer. That number goes there. This number goes there. And that number goes there. So so x is equal to 1 is your asymptote. Y is equal to minus 2 is your asymptote. I'll do one more like this for you. One more, we'll get it right. It's a simple concept, but if you weren't shown how to do it and you didn't practice on it, you will fail it. Here's another one. Minus 3x minus 2 over x minus 1. Rewrite it. So what did I say? You take the x minus 1, you put it out. You put the minus 3x minus 2 inside. So that would be minus 3. Right? Minus 3 times x is minus 3x. Minus 3 times minus 1 is plus 3. Now we subtract. So that becomes plus, that becomes minus. That becomes 0. That's minus. Minus 3, minus 2 minus 3 is how much? Minus 5. So y equals minus 5 over x minus 1 minus 3. Did you all get that one right now? Yay! Now you are clever. Now you are smart. All right. Now give me the equation. Listen, I want the equation of the axis of symmetry with m less than 0. So we found here x is equal to 1, y was equal to 2. x was equal to 1, x was equal to 1, y was equal to 2, x was equal to 1. That's your asymptotes, eh? Now, they wanted the axis of symmetry. Now, for your equation of your axis of symmetry with m less than 0, that means y equals minus x plus c. Now you put y2 equals minus 1 plus c. C equals 2 plus 1. C is equal to 3. So your final answer is y equals minus x with a negative gradient plus 3. There we go. And we're done. Guys, that brings us to the end of functions. Guys, I think you guys all deserve a nice round of applause. We've been sitting here the entire day. We've done a lot of work. We're going in for break now. We come back. We will return from break at 1:15. We start with calculus after the break. Guys, enjoy your break. I'll see you guys back in session at 1:15. Lots of love. Time to love you and leave you. Onliners, Assalamu alaikum. Goodbye, Totsins. See you guys at 1:15. Ooh, I don't have a voice left, boss.
And that's how we come to an end of session 2 of the Awqaf SA Pure Maths Workshop, which is currently held at Al-Falah College in Durban. Do tune in at 1 o'clock. Just today, we will be chatting to Daniel and Amahle Mkhize from Bechet College and the Resfoner Girls High. We will be talking to them as to their experience because they're currently at Al-Falah College. We'll be talking to them as to their experience, how they have been finding, the workshop and so on. So do tune in as we chat to Daniel and Amahle Mkhize of Bechet College and Grosvenor Girls High, respectively. So we also bring you some updates, on the Awqaf SA workshops and the competitions as well. So we urge you to do kindly tune in. And that's it for me from now. Kindly do take that break and refresh so that when session 3 comes back at 1:15, when the session comes back, you are ready for those particular sessions. But from me, that's it for now. Till we meet again at 1 o'clock, where I'll be chatting to Daniel and Amahle. See you. Yeah, ubusathetha ke. Hayi, sukuthi that's that. So ukuthi that's that. Ndiyakhumbula kaloku mbubu usithi. Ubusithi you were so surprised that akakwazi that way, you know, whereas ichomi yakhe ikwazi from. You see, my memory is so good.
But then after that, after I was like, take your time and understand some of that. Like you want to understand. I think, maybe we'll pause that. It's just, he's okay. Like, treatment, like, takes days to reply sometimes, you know. But when he actually treats like me, like he's everything, he's okay. I will stand up.
Umamele. Xa ndikubonisa ivideo yango yabonga ndikustopile. I had to do this quickly because if I don't do it, I'm in deep nonsense. So that's why I had to sort of stop you right there because they were taking a break. So I'm managing the stream. So I'm more like a host now. Yeah, so okay, ubusathetha okay.
Yeah, I'm learning, but like basically, you know, the man, yeah. I feel like I feel the body finals and I just need to
Why?
Yeah. And I just hope even if they have a lot of kids, I think kids do. That's not here. But there's only one school that can take me out of the game because most is part of them. But you are okay, again, the man for kind of school. Oh, we got that, we will. Why was that?
To my man.
But it was a
Yeah? I didn't pause, man. It couldn't do the answer. But it's not working. Okay, Teta again, Mama. Huh? So, Wena, what's your feeling about it? What's your feeling about him? I don't wanna go there.
To be honest, I really have faith in love. I do have faith in love. But right now, I feel like it's too early. It's too early.
Why?
Nah, it's okay. It's fine. I don't know how my mom did it between 4 years. With my dad, I don't know. I did it. And yes, but and my mom got married at the age of 25. But for my mom, they say yes, so many but the age, they say so many. But don't you maybe I have about so many, but then that's what so many. But then where's my at this age? Maybe not the age, maybe next year, the age next year.
Hi.
My mom.
Makhona ngicima, ngifuna ukucima iweb WhatsApp iyaphinda le nto uyithethayo.
Sono una cena. Lascia prendere.
Ai. E ma quando non sono non sono WhatsApp, e appunto
WhatsApp.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care, and water shortages plague communities, and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
And that's it. Welcome to Awqaf SA Pure Maths workshop for grade 12. Today we are doing paper 1. Now, Awqaf SA is a non-profit organization that manages and develops endowment, work funds, and properties to support various social, educational, and economic development projects within the Southern African communities. The organization today hosts its comprehensive grade 12 pure maths exam preparation workshop in association with the Department of Education, iSkill, Thread Waqf, and Al-Falah College. Al-Falah College is a South African co-educational independent Islamic school that has established itself as a center of excellence committed to providing a holistic education in an environment which is infused with Islamic values, catering for the educational needs of students from the foundation phase up to grade 12 in the Durban area. The college environment nurtures the innate ability of all students to explore and discover their God-given talent and achieve their full potential. The plethora of accolades, recognition, and awards received by the school bears testament to their success in achieving their mission based on the 2.6 distinctions per learner and the 100% pass rate since its inception. Al-Falah College maintained its status as one of the top performing schools in the country. With that said, excelling in your maths exams just got a lot easier. We welcome you from all corners of the world. Don't miss out on this opportunity to boost your exam. My name is Khalid Kungani Givaspadi. I am currently at the Awqaf studios in Cape Town. Shortly, I will be chatting with two of the students actually who are currently at the venue at Al-Falah College. The first one will be Daniel from the Beshet College, and the other one will be Amahle Mkhize from the Grosvenor Girls High School. At the moment, we are yet to get them. As soon as they are on the scene, I will make sure that I do bring them on. But in the meantime, you need to know and understand that we do host workshops, from grades 10, 11, up to grade 12. So you need to make sure if you've got a sister of yours, if you've got someone from home who perhaps needs these kinds of workshop, do make sure that you give them or send them the links, because whatever we are doing here, we try and make sure that it is available, to everyone who is interested in these workshops. Now, I don't know why not yet. Okay, it seems like we've got one of the students who has come through already. So what I will be doing now is I will be talking to the students, and we will try and find out as to what's going on, in their world. Hopefully, inshallah, we will get to get a message from them. At the moment, one student is currently online. Let's see if we can get the other one as well. Daniel.
Yeah, that's me. Hey, can you hear me? Hello?
Yes, I can hear you.
Okay, cool.
Daniel, we believe that you are from the Beshet College, which is based in Durban. Can you just briefly tell us, what motivated you to be here? Because we do understand that there are many motivating factors, as to why you will get students attending our Awqaf SA maths workshops. For you personally, what motivated you to be here today?
Oh, what motivated me was just to improve my results, improve my marks. They haven't been the best, so I'm always determined to try and improve them. And I thought coming to this workshop would be the best opportunity for me.
I'm currently experiencing, a bad, but okay. Okay, now can you please repeat that for us, Daniel, as to what exactly motivated you to be part of the workshop?
Can you please repeat? Sorry, can you please repeat the question, please?
Now, can you repeat that for us, Daniel, as to what exactly motivated you to be part of the workshop?
Can you please repeat?
I'm saying that there are many factors that do motivate one person, to be part of the workshop. For you personally, what motivated
Please
you?
repeat the question, please.
Now, can you
Oh,
that for us, Daniel, as
motivated me
to
was
what
again just
exactly
to
motivated
improve.
you to be part of the workshop?
Oh, what motivated me was just to improve my marks. They haven't been the best.
I'm saying that there are many factors that do motivate one person, to be part of the workshop. For you personally, what motivated you?
Yeah, what motivated me was just to improve my marks. That's kind of all there is to it. I want to get to a college, and I think improving my maths mark will help me get there. And so I came to this workshop to get more guidance on how to improve my marks, and I think it's helped me a lot.
Now, Daniel, we understand, that a lot of students, who part of this workshop do make mention that sometimes the pure math students don't have the necessary support or the enough support, because they are termed as the geniuses when it comes to the mathematics subject. Can you kindly tell us your own struggles, in trying to get that motivation?
When it comes to maths specifically, I kind of struggle with when I look at a question paper, and in papers there's a lot happening on the page. Sometimes I start getting overwhelmed, and so I struggle to kind of break it down, and so I get really confused and I get really nervous, and I end up doing my own nonsense. But when you come to something like this, it teaches you how to break it down and kind of analyze the question properly. And so that's why I'm here, just to to understand the questions and how better answer them.
Now, Daniel, my audio issues have been fixed, so I can hear you clearly now, what you are saying. But also, has the workshop lived up to expectations? Because I know sometimes you do go to a place, you're expecting something else and you get something else. Tell us about that.
Can you please repeat? I didn't hear again. Sorry.
I'm saying sometimes, you've got the workshops that you do go through, sometimes they don't live up to expectations. Has the Awqaf SA workshop lived up to your expectations? Has it met your requirements?
Oh, man. Um.
You still can't hear me?
I still can't hear. Oh, just sorry. I'm having so much trouble hearing you. I'm just sorry.
Okay. My question is, how has the Awqaf SA Maths workshop lived up to expectations?
Oh, well, I think I've been pleasantly surprised. I think when you come to a workshop like this, I think there's always a problem with there's too many students, and the teachers and the facilitators aren't given the opportunity to have engage with the learner. But I think with this, I've been surprised. They've addressed all my concerns. I've been well informed, and I think I've learned come I've come to understand concepts that I struggled with before. So yeah, I've been pleasantly surprised with the workshop so far.
Now, thank you very much, Daniel. Now I will call upon Amahle Mkhize. Amahle will also be chatting to us there. Thank you very much, Daniel. And
Thank
that
you.
was Daniel from the Beshit College. And now we have Amahle Mkhize from Grosvenor High School. I don't know if I'm saying it right. Amahle, welcome to Awqaf SA.
Thank you, thank you.
Am I saying the name of your school correctly?
Grosvenor Girls, hi.
Oh, I grew up in Cape Town, so I was saying Grosvenor. Otherwise, how is everything at Grosvenor Girls High?
In terms of studies and
Yes.
matriculation, I'd say it's going fairly well. People are starting to wake up a bit.
People are starting to wake up a bit in September. Do you mean that they were sleeping throughout?
No, I feel like they put a lot of work in at the beginning of the year, and then they started getting trained as the year went on. But I don't know where they're getting the energy from, but it's picking up. It's going back to what we know.
I understand, Amahle, that you are currently at the Al-Falah College. How is the atmosphere there?
The atmosphere is just, I'd say it's people who are here for the same purpose. So it's a very relatable atmosphere. We're all here for one goal, and one goal only is to try as best as we can to improve our mark however we can. Last minute.
Do you believe that the class of 2024 will outsmart, should I say, the class of 2023? Because we had fairly good results last year as well.
Should I answer generally or in terms of my school?
You can answer generally, you can answer in terms of your school. It doesn't
Okay.
matter.
In terms of my school, I feel that we do have the potential to. It's just that I found that during my observation of my school, last year's matriculants were slightly more disciplined. The majority of them were more disciplined than this year's. But this year's matriculants are very smart, they're very capable. If they could just focus and distribute their time evenly, I feel we have a very good chance at doing better than last year's matriculants.
I believe there are students as well from your own high school who are perhaps looking at you now. What will be your message of motivation knowing that that those final examinations are around the corner?
Um, in terms of maths, particularly, I feel that the reason why a lot of students study with maths is the mindset that we come towards maths with. People already have this idea that maths is supposed to be difficult, it's supposed to be stressful, it's supposed to be hard to grasp, but that's not the mindset that they have for other subjects that they do well in. So I feel like first and foremost, change your mindsets. Just think that if I could do this other subject, if I could get this level in these other subjects, surely I can do something to get the same in maths. That's in terms of maths. And then in generally, I just feel that not in a bad way, but at this point in time, I feel that we need to be more selfish. We need to now focus on ourselves just for this last bit of the year, this last most important few months of the year. We just need to be selfish, focus on ourselves, make sure we are maintaining our mental health, as well as making sure we are maintaining a regular study routine.
Now, Amahle, I've been encouraged throughout the programs I've been attending of Awqaf, because I do talk to a lot of students. Most of them want to be architects, most of them want to be doctors, others want to be lawyers, and so on. But we also encourage students as well to become good teachers because we also want good teachers of the pure math subject. Where do we see Amahle in 5 years' time?
Personally, I am going to go into medicine. It's been something that I've been wanting to do ever since I was the age of 4. So I would say that for now, medicine is where I see myself in the next few years, particularly specializing in either neurology or cardiology. I'll just see where my studies next year take me.
Now, when you say that in medicine, I would need you obviously to be specific there. Do you want to be on the lab or you want to be distributing medicine?
I want to be sort of like in the lab. I wouldn't say distributing medicine because people is not really something that I would say I'm gifted in. So I think I'd like to be behind the scenes of medicine.
Amadle, I think we have exhausted our time here because we're supposed to be back at 1:15. But thank you very much for chatting to us. You have been very inspiring to us. Also to Daniel as well, because we had a bit of an issue there with our audio as well. Thank you very much for chatting to us. And that was Amahlem Kize from Grosvenor Girls High School in KZN, chatting to us, telling us there that she is quite excited with the group of students that are currently at her school now, because it seems like that group or that crop of students is a step ahead, of last year's group as well. Amasha also made mention to us that she wants to delve into medicine. So we had to ask her there, what do you mean by medicine, that you want to be in medicine? Do you want to distribute the medicine? Because we've got those people you will find at the clinics, at the hospitals, the practitioning, and also you've got those at the lab creating those drugs and so on. So she says that she wants to be a part of those in the lab, those who will be coming up with those vaccines, when it is necessary to do so. Also, Daniel was talking to us there saying that he was quite surprised, at the success of this Awqaf SA Maths workshop. I think now we have run out of our time. We've got to cut these interviews as well. And you need to know that the Awqaf SA Maths competition, the competitions will be open from January 2025. So from January 2025, the competitions will be there, where in the form of cash prizes from position 1, 2, and 3. And then we've got the most improved as well in the pure maths. So we're not just hosting these workshops, but we try by all means to encourage students, to stay and remain a part of these. I believe Mr. Kota is back from the break, revitalized for that session 3. Mr. Kota, welcome back.
Back, everybody. Hope you guys enjoyed it. How's the comments coming in there in Cape Town there, Khalid?
In Cape Town, we've got the weather from KZN, and in KZN, you've got the weather from Cape Town, even worse.
I'm seeing all the comments coming in here. Thank you so much. Evidence, Marilda, Angel, Anele, Animation, Amina, Gani. Thank you. And I get coffee.
And there's someone here asking, when is paper 2 tomorrow?
Yeah, boy, yes. We're going to finish as much as we can today, as usual. There might be a small component from today that we carry over into tomorrow, but that's not a train smash. But by the end of tomorrow, we would have finished everything. So we're going into calculus now, guys. This is the graveyard shift, the last session for today. And yeah, let's get started, guys. It was an amazing second session and an amazing day for everybody. I hope you guys are all back. Let's go. Yes, same time. Let's get started. I'm clearing the whiteboard. Here we go. Now, I cannot believe that some of you actually in the exams left out your calculus component. I mean, this is a topic where it's out of 40 marks, and you want to be able to total this. Now, we know the first question in calculus is always first principles. So they give us f of x, and I've actually seen learners leave this out in the exam, and for the life of me, I cannot understand why. So they tell you if f of x is equal to minus 2x squared plus 3x, find f dash x, the general gradient. Find the general gradient by first principles. I'm only going to do one here, guys. This was the question in the prelim paper, Gauteng prelim. We are doing the Gauteng prelim 2024 paper. Right. Guys, at this point in time, I cannot every workshop. How many workshops have we done this year? We've probably done about 3 workshops or 4 workshops this year already. Now, 3 times 2 weekends is 6 days. Now, in 6 days of workshops, guys, 6 days, where we've been doing so much of this, by now, you people ought to have mastered it and been able to do this with your eyes closed. Those of you who have just joined us now, you know that there are many more of these workshops, our Awqaf workshops, on YouTube. Master it. You got enough time. You got those holidays. Don't waste your time. Right, let's get started. Like I say, we don't have much time. I know it seems like an entire day, but before you know it, the day is over. I'd love to do one and give you one to do, but we don't have the time. We don't have the capacity. So I might as well just work through it with you. Pay attention. The first thing I want you to do in the exam is you say f of x plus h. Do not go into your formula direct. So now we're going to go minus 2 into x plus h squared plus 3 into x plus h. Now, let's remove the brackets. Minus 2 into x squared plus 2xh plus h squared plus 3x plus 3h. That is equal to minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h. Now we have to substitute this in the formula. Therefore, f dash x is equal to the limit, the maximum limit, as h approaches 0, f of x plus h minus f of x all over h. So now the limit as h approaches 0. Guys, this is a template. You can answer it in the exam exactly the way we do it here. Now, f of x plus h, guys, is this long thing here. Some of you substituted this and you forgot to subtract f of x from it in the exam. How do you expect to get it right? You do half the question. You substitute half your values. Can you expect to get full marks? Never. Never. Let's go. F of x plus h minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus f of x minus 2x squared. So that's plus 2x squared minus 3x. You change both these signs all over h. There we go. This is the limit as h approaches 0, minus 2x squared plus 2x squared, plus 3x minus 3x. We take out h as our highest common factor to cancel with that h, minus 4x minus 2h plus 3 all over h. H and h cancels out. Now you say, but h approaches 0, therefore f dash x is equal to, that's 0, I'm left with minus 4x plus 3. What some of you went and did in the exam, because they told you by first principles, you went, you applied the derivative, you got your answer in one line, you thought you were special. Yeah. You saw what you got. I don't need to tell you. That's all I'm telling you, people. Listen to what I tell you. Follow the processes, follow the protocols, unpack it the way we do it, get your marks. Don't come up with your own systems in the exam. If they say by first principles, it's your instruction to do what? Use your formula. So there we go. And that was your first 4 marks. Some of you didn't even get your first 4 marks in calculus. Congratulations. The next one is obviously, what do you think is going to come after this? You know what your paper looks like. After first principles comes what? Derivative or differentiation, am I right? Right. So now you know you're going to get a differentiation. So let's do differentiation. Onliners, I hope you all got that one right. Onliners, how are we doing? Hit us up in the comments. Talk to us. Where's animation? Judith? Links? Angel? Talk to us. I don't like it when you're quiet. Right, let's clear the board. Next one, f of x is equal to 3x squared over 2 minus 24 times the square root of x. Right, now they're telling you if this is equal to that, calculate, listen, So they combining, they saying calculate f dash 9 for 5 marks. So obviously, you know, you first got to calculate what is f dash x. And after you calculate what is f dash x, then you calculate what is f dash 9. Common sense, not rocket science. Right. So the first thing is we need to differentiate. So f of x. Remember, we need to get this in a straight line. So it's 3 over 2x squared minus 24x to the power half. 1 over 2. Yes or no? Right. There's it. It's in a straight line. Now we say, therefore, f dash x. Forget about f dash 9. F dash 9 you do last. F dash x is what you do first. So f dash x is equal to 2 times 3, 6 over 2 is 3x to the power 1. Remember, derivative, power rule. Minus a half times 24 is 12x. A half minus 1 is minus a half. Yes or no? All I did the derivative. I did the power rule. Therefore, f dash 9 will equal to 6 into 9 minus 12 into 9 to the minus a half. Yes or no? What did I do? Oh, 3. Okay. Testing whether you were paying attention. 3x. See, you guys are clever. You are paying attention. You're not sleeping. Right. So 3 into 9 minus 12 into 9. For every x, we're going to put 9 to the negative a half. Now, whether you want to do this on the calculator or you want to physically go out and do it, it's up to you. Your final answer, let's go. 3 into 9 minus 12 into 9 to the power minus a half. Your answer is 23. That's your final answer. So there we go. 4 marks and 5 marks, your first 9 marks for calculus. Right, now they love giving you this either a tangent or a question with minimum or maximum in terms of A and B. So let's do the question that they gave you from here. And guys, if you have been part of our workshops or you have been working through this, you'll notice that the one that they gave you is one of our templates. One that we have done in class before. In these workshops, we've done it before, just with different values. I'll show it to you now. Many of you will have a look at it now and you'll say, okay, I remember doing this one. Onliners, how are we doing there? Yes, it is 3, Kimberly. Thank you. Thank you, Natasha. Lovely. Okay, good. I'm clearing the board. Let's go. They tell you that g of x is equal to ax squared plus b over x. That's your function. Has a minimum value at x equal 4. The function value, pay attention, at x equal 4 is 96. Find A and B for 6 marks. Now, if my memory serves me correctly, in one of or in our previous workshops, the one that I gave you was if f of x was equal to ax cubed plus bx squared minus 8 has a minimum value at the point P, 2, and 12. Huh? I'm going back now 3 workshops or 2 workshops back. I'm telling you the question I gave you to take down in our previous workshop. The function f of x equals ax cubed plus bx squared minus 8 has a minimum value at the point P, 2, and 12. Find a and b. If you learned that one, you would have got full marks for this one in your exam. But what did we do? We don't listen, isn't it? We don't listen because I get paid to sit here and talk crap, isn't? You don't need to listen to me. Who am I? When I tell you learn something, learn it. If I give you a template, I say it's coming out, it's coming out. If I give you 4 templates, I say one of the 4 templates are coming out in the exam. What is your duty? To learn. But what do? Play PlayStation 5. Enjoy FIFA, Baba. Right. The minimum the minute they tell you minimum or maximum, we know derivative equals 0. The minute in calculus they talk about minimum or maximum, we know derivative is equal to 0. So in your answer, now look here, listen to me. You need 2 equations. You need a function equation, because that's they say function value. And then they talk about minimum or maximum, so you need a derivative equation. So we need 2 equations, equation 1, equation 2, because we need to solve for a and b simultaneously. So they say it has a function value. So that means for g of x, I put 96, is equal to a, x is 4 squared plus b over 4. 96 is equal to 16a plus b over 4 times 4. 96 times 4, 384 is equal to 64a plus b. I'm going to call that equation number 1. Yes or no? It's a function equation, so I just plug and play. You substitute it directly. Derivative. Now I got to say g of x is equal to ax squared plus bx to the minus 1. So g dash x derivative is 2ax minus bx to the minus 2. First derivative. And x is 4. Now we know this is equal to 0. For minimum or maximum, derivative is equal to 0. Now we got x is 4. 2a into 4 minus b into 4 to the minus 2 equals 0. 8a minus b over 4 squared is 16 is equal to 0. 16 times 8 is, what's it, 96? 16 times 8? No, 128. So now I have, I'm just going to write it here on the side because I don't have space. 16 times 8 is 128a minus b is equal to 0. That's equation number 2. Game over. Solve for a and b. Solve for a and b. So, very, very easy. Number 1, you need a function equation. Number 2, you need a derivative equation. Equation number 1, equation number 2, solve simultaneously. That's all. Let's do it together. Remember, they're not telling me about a tangent. If they talk about a tangent, that's something totally different. That you have to do function equal function, gradient equal gradient. I'll give you one example like that after this. So now we got 64a plus b is equal to 384. So b is equal to 384 minus 64a. Here you got minus b. In fact, minus b is equal to minus 128a. So b is equal to 128a. Here you got b is equal to 128a. So b is equal to 128a. Equation number 1, equation number 2. Let's solve simultaneously. If b is equal to that and b is also equal to that, all we can do now is just equate the two. Let's do it together. This is algebra now. 384 minus 64a is equal to 128a. 384 is equal to 128a plus 64a. 384 is equal to 128 plus 64, 192a. A equals 384 over 192. A is equal to 2. B is equal to 128 into 2. B is equal to 256. Done. Game over. Problem solved. 6 marks for Mahala. Function equation, derivative equation. Right. Okay. You all got this? Onliners, how are we doing? You multiplied it by 4. Kalen, we multiplied everything by 4. We multiplied by 4. We multiply by 4. We multiply by 4. So 16 times 4 is 64. 96 times 4 is 3. And then that 4 is out. Right, Kalen? Are we good? Just algebra, guys. Just algebra. Right. I'm clearing. Okay. So now they can even tell you they love this type of question. The function, take this one down. The function f of x is equal to ax, or let's say x cubed plus ax squared minus 10x plus 2 has a tangent given by g of x is equal to minus 6x squared plus 4 no, minus 6x plus 4 minus 6x plus 4 at the point x equal 1. X cubed plus ax squared. Let us put plus bx. Don't make it minus 10x. Make it x cubed plus ax squared plus bx plus 2. Make it plus bx. There we go. And that's a 6. Right. Find a and b for 6 marks. Right? In fact, what we could do, right, let's go. Now they're telling you it's got a tangent. So in our answer, all you do is you say function equal function, gradient equal gradient. That's how you find your two equations. This function must equal to that function, and the gradient of this must equal to the gradient of that. You'll get your two equations and you solve simultaneously. That's all. So let's do it. Function equal function, x cubed plus ax squared plus bx plus 2 will equal to minus 6x plus 4. This is whenever they talk about a tangent, whenever two graphs are tangential, they are equal at that point. Right, at x equal 1. So here we go, 1 cubed plus a into 1 squared plus b into 1 plus 2 minus 6 into 1 plus 4. That's 1 plus a plus b plus 2 equals minus 6 plus 4, minus 2. A plus b is equal to 1 plus 2 is 3. Go on the other side is minus 3. Minus 2 minus 3 is minus 5. That's equation number 1. Gradient equal gradient. So derivative. 3x squared plus 2ax plus b is equal to the gradient of this graph, minus 6. Not 0, because they're not talking about minimum or maximum. The two gradients are equal, and we got x is 1. So 3 into 1 squared plus 2a into 1 plus b is equal to minus 6. 3 plus 2a plus b is equal to minus 6. 2a plus b is equal to minus 6 minus 3 is minus 9. That's equation number 2. And now you can just solve simultaneously. You can do that 2a plus b. 2a plus b is equal to minus 9. I'm now going to subtract the 2. That will become minus. That will become minus. That will become plus. A minus 2a is minus a. Plus b minus b will cancel out. Minus 5 plus 9 is minus 5 plus 9, 4. A equals minus 4. And then a plus b equals minus 5. A minus 4 is equal to minus 5. A is equal to minus 5 plus 4, minus 1. And there we go. And there we go. 6 marks, you solve simultaneously. But the main thing here is to get your two equations. Function equal function, gradient equal gradient. Now the new style of asking your calculus cubic graphs is what? Giving you the derivative graph. Sketched is the derivative. So the derivative of a cube is a parabola. There we go. Thanks, Andile. Right, Kalen. Right, Dimpo. I'd love for them to put this in the exams. At least we know we've done it. Okay. Now watch. Right, I'm clearing the board. Right, this is what they gave you now in Gauteng prelims. They gave you that. Whoops, they gave you that. And they give you a parabola. Take this one down. They give you a straight line as well. And this is in calculus. This is not even functions, eh? But the same rules that apply, they say this is G dash X, sorry. This graph is G dash X, and this graph is H. and then they give you a dotted line here. They tell you that point is B, that point is A. This point is D, 6 and 0. D, 6 and 0. This is from your prelim paper, guys. C, minus 2 and 0. C, minus 2 and 0. Now, there's so many questions they can ask you on this. They can build up. Do you know, just on these two graphs, they can build up about 30 marks just on this. They can build up questions worth 30 to 40 marks only on these two graphs. They can ask you concave up, concave down, increasing, decreasing. They can ask you to give the x values of the turning point of your original. Find the derivative. They can ask you, give the equation of G. There's so much they can ask you on this. Right. And this is point E. That's point E. Right, the graphs of G dash X, so they tell us that G dash X, parabola, AX squared plus BX plus C. H of X is equal to 2X minus 4. G dash is the derivative of the cubic function. Right, question number 1, they want the coordinates of E. Now that's easy. The coordinates of E. E's coordinates is 0 on the X. So this is the way you write it in the exam. E, 0 on the X. And it's the point where the two graphs meet. So it must be negative 4. So let's go here. Let's put 0 and negative 4. 0 and negative 4. That's E's coordinates. Question number 2. They want the equation. Find the derivative. Find the derivative. Basically, what are they asking you for here? They're asking you for the equation of G dash X. Yes or no? Yes or no, guys? Okay. Now, how would you find the derivative here? And it's worth 5 marks. What are they asking you? They're asking you to find the equation of a parabola. So where do we begin? Whenever two x-intercepts and a point is given, we go y equals a into x minus x1 into x minus x2. Did you guys forget that? I hope you didn't. So you can call this one x1, you can call this one x2, and this is x and that is y. So let's go. We're solving for a. Minus 4 is equal to a into x minus 2. No, it's 0. X is 0. Minus 2 plus 2 into 0 minus 6. So minus 4 is equal to a into 2 into minus 6. Minus 4 is equal to minus 12a. A equals minus 4 over minus 12. Negative and negative will cancel out. 4 over 12 is 1 over 3. So y equals 1 over 3 into x plus 2 into x minus 6. Y or G dash x is equal to a third into x squared plus 2 minus 6 is minus 4x minus 12. Here's your final answer. G dash x is equal to a third x squared minus 4 over 3x minus 12 divided by 3 is 4. We don't think we right. We know we right because that point and that point there must be the same point. Yes or no? Grade 12s? Yes or no? Lovely. Write down the x coordinate of the point of inflection of G. Right, question number 3. Question number 3, they want the x coordinate of the point of inflection of G. Right? And then I'm going to, they can even ask you, I'm just changing some of the questions here. Now they can ask you after that, for which values of x is the graph concave up or concave down? Right? So now let's do number 4. I want the value or the values of x for which the graph is concave up or concave down. And not only that, where is G increasing and where is G decreasing? Right. Question number 5. I want to know where is G of x increasing and where is G of x decreasing. Pay attention. This is very important work, guys. Right. The x coordinate of the point of inflection is the turning point of my derivative. The x coordinate of point of inflection is my x value, my x coordinate of the derivative. Second derivative, the turning point of the derivative of the derivative, the second derivative. So that means minus b over 2a. So what did we have, guys? What was our original graph? What was our original graph? Our graph was g dash x was equal to, what was it? A third. X squared minus 4 over 3x minus 12. Am I right? Minus 4. So g double dash x will equal to 2 over 3x minus 4 over 3. Yes or no? Is equal to 0. So 2 over 3x is equal to 4 over 3 times 3 times 3. 2x equal 4. X is equal to how much? 2. That's your answer. That's your answer for the first question. This is your answer for the x coordinate of the point of inflection. You could have done it this way, or the other way you could have done it, you could have said a third x squared minus 4 over 3x minus 4. X is equal to minus b over 2a. The turning point, the x value of the turning point of this, you would have got x is equal to 2. Same answer. Agreed? Onliners, we okay? You following? Good, good. Let's go. Right, so we know now, guys, we know that this point here is 2. We're not worried about its y value. Shh. Where is it concave up? Concave up is from point of inflection up. So it's from 2 to positive infinity. Where is it concave down? So that's concave up. Concave down will come down this way. from negative infinity up to 2. Do not put including 2. Point of inflection, nothing's happening there. Right, so for concave up and concave down, we look at the point of inflection, the x value of your point of inflection. For increasing and decreasing, we look at the x value of our turning points of original. Make a note of this. Whenever they're asking you where is the graph increasing or decreasing, you look at the x values of the original graph. Now, we're not given the original graph, but we're given the derivative. We know that the turning points here are the x values of our graph. That means if our graph looked like this, just to show you, if our graph looked like that, then this point here is -2, and that point there is how much? 6. Very important that you understand from a derivative graph that the two x-intercepts here are the two x values of your turning point of your original. Are you guys following? So now where is it increasing? It's increasing there and it's increasing there. So it's increasing from negative infinity up to -2, or from 6 to positive infinity. And where is it decreasing? Between the two, between -2 and 6. There we go. It's decreasing there. That's where it's decreasing, between these 2 points. It's increasing there and it's increasing there. So for increasing and decreasing, we look at the original graph. For concave up, concave down, we look at the derivative graph. Make sense? Good. Right. Now they put one question here, the last question in here, just to knock you silly. Right? The last question. And then we're going to do the one where the calculus application question that they gave you in terms of area and perimeter from the Gauteng paper. And that will wrap up your calculus. Right. Pay attention. They tell you, shh, so that's over. That's all over. They tell you that h of x is equal to 4x cubed plus 5x. Take this down. Is it possible? Substantiate whether it is possible to draw a tangent to the graph. Is it possible to draw a tangent to h that has a negative gradient? A gradient less than 0. Why? And only 2 marks. It's your last question in calculus. Your normal, in the calculating part of calculus, it's your last question. Then we're going to go into the application. And that's very easy. I'll show you how it's done. It wasn't, honestly, I seen learners leave it out, blank. They left probably about 15 to 20 marks. They just left it out. I can't understand why. Right. Now, what is the gradient of this graph? This is the original graph. What would the gradient be? H dash x. Am I right? So h dash x is what? 12x squared plus 5. Yes or no? If I do the power rule here, 12x squared plus 5. Now 12x squared, that means this graph has always a positive gradient. Why? Because x squared is positive. A positive times a positive is a positive, plus a positive will always equal to what? A positive. So 8 dash x is 12x squared plus 5, has always a positive gradient. You can even write, since x squared is always positive. Therefore, is it possible to draw a tangent to that has a gradient less than 0? No. Not possible. Because the gradient of this will always have a positive gradient. That's your answer. You got 2 marks for that. Are you guys with me? This will always be positive. Therefore, it's impossible for a tangent to this graph to have a negative gradient. Impossible. Why? Because the gradient to the graph is always positive. Are you guys with me? Good. Onliners? Right, let's go. Next one, I'm erasing. Let's clear the frame. Clear board. Right, take this one down. Take this one. Oh, let me see, where can I draw it? Let's draw it on this side. Okay, so they give you this. They do that. They do this. They do that. They give us, whoopsie, give us that. They give us that. And they give us this. Right. They tell you that's 90 degrees, 90 degrees, 90 degrees. That's also 90. This is C. That is B. This is A. That point there is A. They tell you this is F. This is E. This is D. And that's Y. Anything else? And they tell you that this small piece here is, so that's Y. And that piece there is X, and that piece is equal to that piece. All right, here goes. The diagram below shows the plan for a veranda which is to be built on the corner of a cottage. A railing A, B, C, D, E. A, B, C, D, E is the railing. So they tell you A, B, C, D, E is a railing. A metal railing. Right, it's given that AB equal DE equal X. AB equals DE equals X. BC equals CD. BC equals CD. Where's CD? Oh, CD. BC equals CD, which is equal to Y. Okay. And the length of the railing must be, 30 meters. Now, one question for 8 marks. Calculate the value of X and Y for which the veranda will have a maximum area. Question, here's the question. Calculate X and Y for maximum area. For 8 marks. Right. Now, what do we need to do in a situation like this? Firstly, we know that we're talking about area, but they're telling me the length of it is 30 meters, so we know that they're talking about perimeter. Perimeter is length around, yes or no? Okay. Now, when they're telling you to solve for X and Y, what you want to do, easy. Firstly, you need to get the area in terms of X and Y. Don't we want the area first in terms of X and Y? Then we do derivative to find maximum X. Then we take X and we put it into the original to get maximum Y. Yes or no? Right. So let's label this diagram as much as we can. What do we have? So if this piece here is x, that piece is x. Yes or no? That means this piece here, that piece there is what? Y minus x. Because it's a rectangle, so this piece will equal. Remember, this entire piece up to here is y. That entire piece is y. That small piece is x. So what would this be? Y minus x. Yes or no? And if this whole length is y, and that small piece is x, that means this piece here is also y minus x. Yes or no? Okay. Now let's first look at, they spoke about the length. So when they speak about length, what are they talking about? Perimeter, not area. When they talk about the length around, what are they talking about? Perimeter. So what would the perimeter of this here be? It would be that plus that plus that plus that plus that. Am I right? Isn't the perimeter going to equal to BC plus CD plus DE plus FE plus FA plus AB? Yes or no? That plus that plus that plus that plus that plus that must equal to how much? Must equal to 30. Yes or no? So what is B? BC? Y. What is CD? Y. What is DE? X. What's FE? What's AF? What's AB? Yes or no? So 1 2 3 4. So I'm left with 4y. Yes or no? X minus x is 0. X minus x again plus x is 0. So 4y is equal to 30. So what is y equal to? 30 over 4. So y equal to 30 over 4. Let's just double check 30. Let's double check here. We got BC, which is y, plus x plus y minus x plus y minus x plus that. Okay, which is 15 over 2, 7,5. Right. What about the area? Now, area of this entire shape is going to be the area of the big rectangle minus the area of the small rectangle. Area is equal to area of the big rectangle minus area of the small rectangle. So area is equal to y times y, which is y squared, minus the area of the small triangle is y minus x squared. Yes or no? That is equal to y squared minus into, that would be y squared minus 2xy plus x squared, which is equal to y squared minus y squared plus 2xy minus x squared. So that means area is equal to y squared minus y squared is, so we got minus x squared plus 2xy. Yes or no? Take that down. Take that down. So now we got the area. We know that the area of this entire thing, area is equal to minus x squared plus 2xy. Now remember, we still need to find the derivative and we need to find for maximum area. Now, just going back to the perimeter here. Going back to the perimeter here. It's fine. You can put this one here at the bottom down. I'm just going back to the perimeter here on the top. We know AB plus BC plus CD. AB plus BC. AB plus BC plus CD plus DE. Oh, sorry. This here is the cottage. So this here, right. Pay attention here. Remember they said that the railing must go around the cottage. Here's your cottage. So that means it's that plus that plus that plus that. So that means your perimeter is equal to AB plus BC plus CD plus DE. So 30 is equal to, if you add all this up, x plus y plus y plus x. So 30 is equal to 2x plus 2y. Therefore, if I divided everything by 2, x plus y is equal to, therefore, x plus y is equal to, if I divided everything by 2, what am I left with? 15. So y equals 15 minus x. Right. Now, so this was your, watch here. That was your perimeter formula, equation number 1. This was your area formula, equation number 2. Now remember, when we're differentiating, we differentiate y in terms of x. So watch what we do. It's simple. You got y. You got y. So take that y and put it into there. Right, I'm just erasing here on the side. Right, so here we go. We got equation, and we got a perimeter equation, we got an area equation. Right, so let's go. So we got area is equal to 2xy minus x squared. I'm now going to, I got y. Y is 15 minus x. Area is equal to 2x. For every y, 15 minus x squared. Area is equal to 30x minus 2x squared minus x squared. Area is equal to 30x minus 3x squared. Therefore, dA over dx is equal to 30 minus 6x. For minimum or maximum, derivative must equal to 0. Minus 6x will equal to minus 30. X is equal to 5. Yeah, boy, yes. And y equals 15 minus, so y equals 15 minus x, 15 minus 5, y is equal to 10. Y is equal to 10, x is equal to 5. All right. Yes or no, grade 12s? And that brings us to the end of calculus. That brings us to the end of calculus. Right. Let's do some probability. Let's do some probability. Let's do some probability. How's our timing going, guys? How's our time? 20 past 2. Before you know it, it's the last 30. So let's do some probability and some finance, and that should take us to the end of today. By now, you should be sitting with about 80% already for your paper. Functions, we smashed. Calculus, we smashed. Algebra, smashed. Your minds are in the gutters. Gutter brains. Right. Let's go, guys. Let's go, let's go, let's go. Okay, let's look at probability, guys. Let's look at probability. Okay. They tell you, let's just say, they tell you a 4-digit code or a 5-digit code with using the numbers 0 to 9 excludes the number 2 and 5. How many 5-digit codes can be made with repetition and without repetition? Right. So you got a 5-digit lock, bicycle lock, or an alarm code at your house. Using the numbers 0 to 9, but we cannot use the numbers 2 and 5. How many 5-digit codes can be made with repetition? So it's very easy. 1, 2, 3, 4, 5. There's your 5 digits. In space number 1, remember we just multiplied. This is what we call fundamental counting principle, FCP. When you multiply your probabilities, it's called fundamental counting principle. When it's multiplying all the way down to 1, it's called factorial. That's the difference between fundamental counting principle and factorial. So between 0 and 9, how many numbers are there? Oh, not between 0 and 9, from 0 to 9. 10. There's 10 numbers. But we can't use the number 2 and 5. That means in the first place, from a total of 10 numbers, I'm excluding 2 numbers. How many numbers can I only put in or use here? 8. But they tell me with repetition. That means I can repeat here as well. So it's 8 times 8 times 8 times 8 times 8. That's it. So my answer is 8 to the power 5. Yes or no? Your answer is 32,768 different combinations. And obviously without repetition, 1, 2, 3, 4, 5, we can use 8 numbers here. We use 1 number here. How many numbers left to use? 7. We use 2 numbers. How many? 6, 5, 4. It's still FCP. It's not factorial. We're not multiplying it all the way to the number 1. So it's 8 times 7 times 6 times 5 times 4. $6,720. Yes or no? Right. Now let's do factorials. Now let's do factorials. Onliners, we okay? Let's go. So let's do this. Let's use, since we are here at Al-Falah in KZN, so let's write Al-Falah. Sure. You want to write Al-Falah College or we just write Al-Falah? Yeah, you know how big it becomes, because if I have to write now college, it's rough. How many numbers are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh my God, this thing goes crazy. Let me just see, 15 factorial. Whoa. All right, let's leave it as Al-Falah College like this. All right, let's stop it like this. Al-Falah College. Right. Question number 1. In how many ways can the word Al-Falah College, if you took all these letters like Scrabble letters and wrote them on a piece of paper or on a block, you mix them all up, the word doesn't need to make sense. But in how many different combinations can you have? So in how many ways can the above word be written? How many different combinations are there? So it's very simple. Right. So we underline them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you take your total factorial, you divide it by however many letters are repeated. So my total factorial is 12 factorial divided by, how many A's do I have? 1, 2, 3, I got 4 A's. Multiply by how many L's? 1, 2, 3, 4. Anything else that I got? No, I got 1 F, 1 H, 1 C, 1 O. So that's it. So it's 12 factorial. So go to your calculator, you say 12 factorial, which is 12 times 11 times 10 times 9 times 8 times 6 times 5 times 4 times 3 times 2 times 1, divided by 4 factorial, which is 4 times 3 times 2 times 1, multiply by 4 factorial, which is the same. 831,600 ways. So there are 831,600 different combinations of arranging these letters. Right, question number 2. In how many ways can the above word be written if it has to start and end with an L? In how many ways can the above word be written if it starts and ends with an L, with the letter L? Let's check our onliners. 831,600, Amina. Perfect. Yeah, no problem, Angel. You use the NPR and you get the same answer for non-repeating. Perfect. Right. Now it needs to start and end with the letter L. Pay attention. So now you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has to start and end with an L. So these two are fixed. So how many do we have in between? 12 minus 2 is how much? So we got 10 factorial divided by whatever is repeated. How many are repeated now? You got 4 A's and now you only got 2 L's. Am I right? So let's go. We go 10 factorial over 4 factorial multiplied by 2 factorial. 75,600 ways. Right. Question number 3. Calculate the probability that a word chosen, the probability that a word chosen will start and end with an L. So the probability of the event would be 75,600 divided by 831,600. Remember our total probabilities that we had. Your answer is 1 out of 11 or 0.09. We'll do one more in probability. Remember, you need to know from grade 11 your two-way contingency table to prove mutually exclusive and independent events. You need to know your tree diagram. You need to know your two-circle and three-circle Venn diagrams. I'm just doing the grade 12 component for now. Okay. I'm erasing this. Let's do this. A motor car dealer, take this one down. A motor car dealer has 4 BMWs and 6 Mercs. If 3 BMWs need to be placed next to each other, in how many ways can all the cars be arranged? Here we go. Let's check our timing out. It's 2:30. We're going to finish up with this and then we're going to do some finance. I'll give you guys about a 5 or 7 minute comfort break, bathroom break. We'll come back, we'll finish up finance, and we'll definitely do the finance right through until I'll show you the important ones to focus on in terms of finance, and then we are done. Tomorrow morning, we'll start off. We could start off with some sequences and series problems, but that's quite easy. Guys, sequences and series can't be the section that's killing you. And then paper 2. Right. Take this. Right, let's do this one, and then I'll give you guys 7 minute comfort break. So we've got 4 BMWs and 6 Mercs. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. So BMW, B, and 6 Mercs. M. They tell you 3 BMWs need to be grouped, so you can group any 3, like that. You can do this in the exam, guys. Exactly the way I'm doing it here, you can do it in your exam. Right. Now, this is equal to. Now, how many spaces have you got? You got 1. This whole thing is 1 space. So that's 2, 3, 4, 5, 6, 7, 8. So it's 8 ticks. Multiplied by the number in the group, multiplied by 3. So we got 8 factorial multiplied, so it's 8 spaces, multiplied by the number in the space or in the group. So 8 factorial multiplied by 3 factorial, and that gives you 241,920 ways. Learn this model. Okay, let's look at our timing, guys, because we're in here from 1:15, 2:15. We're in for 1 hour, 20 minutes already. It's now going for 25 to 3 at 22. So you got 7 minutes. Guys, I'm giving you guys a 7-minute bathroom break, coffee break, tea break, call it whatever you want to. A 7-minute comfort break. We come back and we will finish up at 3 o'clock. Okay, I see you guys. See you guys in 7 minutes. I need a vocal cord break.
So that was Mr. Kota just taking a comfort break there. That's the Maths Paper 1 of the Grade 12 Maths Workshop coming to you live from Alphala College in KwaZulu-Natal. Hope that you are deriving great benefit from this session. Please keep that comments flowing. Let us know how you're feeling. Are you feeling amped? Are you feeling motivated for your Grade 12 Maths examination? Also, I think Khalid did also mention we will be hosting a competition. It will open up in January 2025. It's very important for all participants to have registered for this maths workshop. So you will receive an email from Awqaf. All that we will need is your July examination result, as well as, because you're in grade 12, your results will be released by January, perhaps the first week or second week of Jan, and that's when we open up the competition. There's cash prizes, first prize, second prize, third prize, and the most improved. So there's hard cash up for grabs, 800, 700, 500, and so on, hard cash coming to you. In 2022, we had Rorisang, and he scored 100% in mathematics. He was a top winner of 2022. He continues to be a source of inspiration for this project. Last year, some of our winners walked away with some hard cash. They scored 99% and 94%, respectively, positions 1 and 2. Tell me, Khalid, how's things going on your side? How's the session been on your side? I would really like to engage with you. Khalid has been the one moderating the session. So let me know how things is going on your side there, Khalid. Let's get you on.
Everything has been running good up until now. Am I audible?
Yes, I can hear you loud and clear.
Just a few minutes ago, we spoke with Daniel from the Bishop College in KZ, and he was saying to us that he's quite surprised, at the level of this kind of workshop, because for him, it was all about just trying to look at some sort of other avenues. He was exploring more than anything. But in this workshop, he has found a home, that he is trying by all means to make sure that he doesn't miss any of these workshops, because it comes in handy for him. Then I also spoke to Amahlem Kize of the Gronosfer Girls High School. I still don't know how to say
It's
the
a
name
mouthful.
Yeah, it's a mouthful for me. I still don't know how to mention that, even though when she said it with so much ease. But I must say that the way in which she applied herself, to see her with those badges. Just a few minutes ago, I was speaking with one of my friends saying that I was watching the interviews, and she is currently doing her grade 12, and she was saying to me that looking at Amahle, you know, the kind of badges she has, it makes us think that we are far behind, you know. There's a lot to be done in terms of education and so on. So she didn't just speak, you know, on this Awqaf platform, but she sort of inspired others because the girl I was talking to is a grade 12 student, you know, from Voortrekker High School here in Cape Town, even though she's not doing the pure maths, but she came in and sort of watched the lessons, you know, and she was saying that she wants to become a nurse and she will try by all means, you know, motivate herself to come back to do pure maths, because in the way in which through this Awqaf workshop it has been simplified for her, it is simply a motivation.
So there we go. So these sessions, you know, Khalid has put a lot of effort also in interviewing some of the learners. So if you came into the session and you were demotivated, overstressed, overwhelmed, may this be a source of relief to you, to calm you down, that there is help on the way, you know. So Angel has just got a question over there. So yes, we can just put Angel's question over there on the screen. Let's show that. Yeah, so Angel's got a question. Can online students also? Yes, it's all for online students as well as the students that's part of the cohort. Essentially, you know, even for the in-person cohort of learners, you do yourself a favor and do register for the workshop. You see, if you are a registered student online, um, if you have not registered, do register, because we have your email addresses and we're going to send an email communication to you. So all the grade 12 learners, whether you've joined in May or September or in August workshop, we have all of your email addresses. This is why we need you to register. We'll be sending out that email communication to one and all. It's merely an online form. You need to submit your results, and we'll collate that, and then we'll let you know. And yes, this competition will open up in Jan 2025. So this will be applicable for grade 12, 11, and 10. Any other feedbacks, anything that stood out for you, Khalid? I think Kauta is ready.
I think the cohort of learners that we have at Al-Falah College, you know, they've been very disciplined. If there's something that stood out for me, because sometimes we do have, you know, those students who are overly excited, you know, to such an extent that they end up, you know, disturbing Mr. Kota. But from these students, what I must say is that they are very, very disciplined, and I am quite happy that we have that kind of discipline, because more than anything, they are the seniors and they should show that. And also, Amahle made mention to us that, you know, the energy there is the energy of people who are there for the same goal, who are trying to improve themselves. So big ups to them.
Mr. Kauta, take the show away.
Here we go, here we go. The graveyard shift, the last 15 minutes for today. We're all supercharged, we're all energized and fresh, ready for action for the last session for today. And tomorrow is going to be another bumper day. Thank you, guys. Lazarus Salala, feeling much motivated indeed for the sterling workshop. Well executed and keeping math simple and simplified. Thank you so much, Mr. Lazarus. To answer Angel Nadi, can online students also join the competition? Yes, of course. The online competition is for everybody. Please submit all your results to Awqaf and you will be getting cash prizes at the end of the year. Guys, today is only day one. We still have day two to go tomorrow. The fun starts tomorrow. Trigonometry, analytics, circle analytics, and Euclidean. Right. Let's look at the financial component from the Gauteng paper. Let's go, guys. Let's go, let's go, let's go. We are back in session with financial. At what annual percentage interest rate? Now, you guys, many learners mess this one up. Take this one down. At what annual percentage interest rate? Take this one down, guys. Welcome back, welcome back, welcome back. Compounded quarterly. Should a lump sum be invested in order to double in its value over a period of 6 years? Okay, here we go. Guys, we're going to try and finish the entire financial component for this prelim paper. Okay, let's do it together. Guys, a lump sum be invested in order to double. So there's key words here. They're looking for percentage. It's compound interest. It's compounded quarterly. Should a lump sum be invested in order to double in its value over a period of 6 years? So this is what I want you to do in the exam. Circle all these important keywords. This will tell you which formula to use. So A equals P into 1 plus I to the power n. Compound interest, yes or no? If your original value is P, for it to double, that means your final amount will be 2 times P, double it, into 1 plus, at what interest rate? So this is, and they say compounded quarterly, so it's not just I, it's I over 4. To the power n is 4 times 6 years. What letter are we looking for? I. Right. Now remember something. So let's do the calculation on the side. 2P is equal to P into 1 plus I over 4 to the power 4 times 6 is 24. Now we got a P on both sides. So we divide this side by P. What I do on the right, I do on the... So what am I left with? I'm left with 2 is equal to 1 plus I over 4 to the power 24. Now many of you messed this one up royally in the exam. You guys rounded up. No rounding off. You only round up in your final answer correct to 2 decimal places. So if this was squared, to get to I, we'd find the square root. If this was cube, we'd find the cube root. It's to the power 24. So watch what we do. 1 plus I over 4 is equal to the 24th root of 2. Now we take the plus 1, we take it on the other side as minus 1. So that's done. I want I. I multiply by 4, I multiply. This is what your answer would look like. 4 times the 24th root of 2 minus 1. I equals. You're making I the subject of the formula. So let's go into our calculators. We say 4 open brackets. The 24th root of 2 Go to the side, minus 1 close brackets equals. You get 0,1172, which is 11I is equal to 11,72% per annum, compounded quarterly. Do not round it off. It's not 12% or 0,18. They will subtract marks from you. So please make sure you get this one correct. And this is where we're going to round up, guys. We're going to round up on this final payment model. We've got about 10 minutes to go before 3 o'clock. Please learn this. Right. So they say, Michaela buys furniture to the value of 10,000 rand. So Michaela buys furniture for 10,000 rand. She borrows the money on 1st February 2023 from a financial institution that charges an interest rate of 9.5% per annum, 9.5% per annum, compounded monthly. Michaela agrees to pay monthly installments of 450 rand. So she decides to pay 450 rand per month. The loan agreement allows Michaela to start paying equal monthly installments from 1st August. So this was 1st February 2023. But the loan starts on 1st August 2023. Let's go. Here comes your questions, 3, 4. Remember, the total marks for finance is only 15 marks. 13 to 15 marks in your final exams. But it's marks you don't want to throw away. Question number 1. Calculate the total amount owing on 1st July 2023. Calculate the total amount owing on 1 July 2023. Number 2, how many months will it take Michaela to pay back the loan? To repay the loan. What is the balance of the loan immediately after Michaela has made the 25th payment? Calculate the balance. What is the balance of the loan immediately? So the balance outstanding. Calculate the balance outstanding on the loan after the 25th payment. Right, let's go. Take this one down. This is where we're going to wrap up today, guys. Nine comma 5. Let's just work this one out. Okay. So let's see. Let's go here. 1st February. So she must be charged interest for February, the whole of February, March, April, May, June, July. No, but they say calculate the total amount owing on 1st of July. So it's February, March, April, May, June. So till the end of June, till the 30th of June. 31st of June, 30th of June. Till the 30th of June, it's how many months? 5 months. That means she must be charged interest for a period of how many months? 5 months. Very good. So I'm just going to do it here on the side. So A equal P into 1 plus, I'm answering question number 1. Please look at the dates. Look at the timeline. The timeline is 1st of Feb and they want 1st of July, so basically end of June. To the power 5. So A is equal to 10,000 into 1 plus 0,095, 9.5% compounded monthly, divided by 12 to the power 5. Now we go 10,000 into 1 plus fraction 0,095 over 12, close brackets, to the power 5 months. 5 payments. So 10,402. Your answer is 10,402,15. That's the answer for question number 1. I want you guys to try this one. How many months back to repay the loan? Because she agreed at 450 Rand per month. So let's go. Let's do this one. We don't have much time. I'd love to allow you to do this one on your own. It's a loan. It's a loan. So is it, just remember, FSPL. Flippin' stupid people. Future value for savings, present value for loans. So PV is equal to X into 1 minus 1 plus I to the minus N all over I. So to repay the loan, remember she's only starting, don't use the 10,000. It's 10,402,15. Because she's only, remember the value of the loan has increased. She's only going to start paying in August. If you use the 10,000, you might have thought that you will pass. You will fail nicely. Now you put the 450 into 1 minus 1 plus I. 0,095 over 12 to the power minus N all over I. 0,095 over 12. We now need to make N the subject of the formula. So we know at the end it's going to ultimately end up in logs. Yes or no? So where do we start? We start with this and we multiply it by that. So 0,095 divided by 12 multiplied by 10,402,15. And then we divide it by the 450. Okay, so it gives you a big amount here. 0,183,000,787. So that's out, that's out, that's out. The plus 1 will come onto the other side as minus 1. This plus 1 here will come on that side as minus 1. Is equal to minus into. So let's say minus 1. So I get minus 0,8169999213 is equal to minus into, if I do that on my calculator, 1 plus fraction 0,095 over 12. I get 2419 over 2400 to the power minus n. That and that will cancel out. Now we attach a log on both sides. So bring the minus n in front of the log. So minus n log 2419 over 2400 will equal to log 0.816999213. I'm going to just move up here to, okay. Let's go up. Minus n will equal to log 0.816999213 divided by log 2419, sorry, 2419 over 2400. Minus n will equal to, go to your calculators, log 0.816999213 divided by log fraction 2419 over 2400, boom, equals minus 25,63, negative and negative. You must get a positive answer. N is equal to, what was the question? Did they say how many full payments and how many part payments, or how many, they just asked for how many months will it take? How many months? 26 months. So she will make 25 full months of 450 Rand, and she'll make one payment less than 450. Right. What is the balance of the loan immediately after Michaela has made the 25th payment? Right, basically it's like saying calculate the final payment. So watch how we do it. After the 25th payment, after this 25th payment, so this is what we call the final payment model. How much time do we have? 1 minute. Ish, it's time. All right, you can do the last one for tomorrow morning. Boys and girls, thank you very much. It's been an amazing day. You can do the last one for tomorrow morning. We'll do it. I don't even have a voice left. I see your buses are getting crazy here. Boys and girls, thank you so much. There we go. Thank you so much. Tomorrow, paper 2. Tomorrow, paper 2. Boys and girls, thank you. Onliners, love you lots. And yeah, good luck. Have a lovely day, the rest of the day, and we'll see you bright and fresh and early, 9 o'clock tomorrow. Asanain, take it away.
So that's where we leave it off. That was grade 12 Maths Paper 1 with Mr. Kota and the team there at Alphala College. Gratitude, word of gratitude to Mr. Zafar Ahmed and Dr. Rakesh Singh, as well as Faisal Kathri and his team from Kathri Sound for providing the AV support, as well as Muksin. We'll be hosting the grade 12 Maths Paper 2 session tomorrow. And all over to you, Khalid, for your concluding remarks.
Thank you very much. And that was Hassanin Abdullah, the project manager of Awqaf SA. And that's where we stop for today. We know that we were doing Awqaf SA Pure Maths preparation workshop, which was paper 1 today. And we thank very well Mr. Kota there waving to us. We know that he does so much, the efforts he puts in, to try and facilitate a workshop of this sort is not so easy. For our teachers, that are teaching mathematics at school, they've got a 45-minute period or a 45-minute double period. but for him, he sort of does so much, so we need to thank him very well, for the dedication and the effort which he puts in, because for a maths workshop, you don't just come in and sit there in front of the students and that's it, but there is preparation that goes, because there are many methods of doing the same thing. So we thank him very well. And that's it from us, because we have been coming live from Al Falah College in Durban. There are many schools there that are on the ground, and we spoke to some of the schools that are there. One of them is Beshet College, of which we spoke to Daniel, who was saying that he was quite surprised, at the level of this Awqaf SA Pure Maths workshops. He was just browsing through, trying to sort of look at different avenues, in which he can try and apply, to raise his mark. But he was quite surprised at what he found. And then we also spoke to Amahlem Kize, a student from the Grosvenor Girls High School, also in KZN, saying to us that she was quite pleased to be part of this workshop, and asking her about the environment in which she found herself in, and also the atmosphere there at Al Falah College. She said to us that it's a cohort of students, a cohort of learners, who are sort of have the same goal. Therefore, there was discipline, and also saying that even from her school, there is discipline, and they think that they can do better than those who were there last year. So if you'd like um, to donate, towards this, as you know, that Awqaf SA, it depends on the work of funds, the endowment, and so on. So you can do that by just scanning this. And that's it. That's where we leave it. From myself, Khalid Kungan, give us party up until tomorrow at 1:30.